1, 2, 1, 2. Cool. Let's start sitting down. We're going to get started. Look at us, improving day over day, no projector problems. It's pretty exciting. Kinda. All right. So show of hands, who came to karaoke last night? We're going to show pictures and create FOMO for 2025 because you're not going to get this for a full year.
Yeah, missed out.
Another quick show of hands. Who came to SCaLE for NixCon? Holy shit, wait a second. So I'm sorry. Elon asked us about this because he wants to know. We need to take a picture of that. So,
Hands back up. All right.
thank you. Next year we're going to be doing NixCon over there, and we'll let SCaLE co-locate with us. I'm kidding. They were lovely. All right, so welcome to the second day of NixCon North America for the very first time. This day is going to be a mix of talks from a lot of awesome people and an unconference. So we're going to be testing this out, obviously, like we've been testing out everything that we've been doing up until right now. Unconference, if folks are not familiar with it, kind of like how Zach ran lightning talks yesterday, you're all going to come up, give a topic that you want to talk about. Zach's going to do some AI brain thinking in his mind about how to allocate different tables and rooms and areas for you guys to have these discussions. And then we're going to split off and do that, which I think is pretty exciting. It actually creates a lot of good conversation. So thank you all for making it on time. I'm sure there's going to be a bunch of people that are late, but that's reasonable because a lot of people had fun yesterday until 2 a.m. doing karaoke. And with that, I'm going to hand it over to Zach.
Yeah, I don't know about 2 a.m., but we had fun. Yeah, so Michael Stonky, legend. Camille, legend. Ron got serenaded, but didn't sing anything because he chickened out. Yep. Yeah, so I'm not sure I have anything else to really add. I'm excited for the talks today. Our first speaker is Z. With that, I think we'll go ahead and get started. And
just a quick,
yeah, maybe I'm wrong.
quick few notes. Thank you again to the awesome volunteers. A quick applause for them. Thank you guys.
Yeah. Can you go back to the sessionized thing?
Yeah. Sessionized? Oh, this one.
Yeah, so this QR code is for sessionized. This is where the whole schedule is. So you can see which talks are coming up, yada, yada, yada. You can favorite the ones that you absolutely don't want to miss, that kind of thing. Yeah, so that is our portal for the whole event. So that's definitely useful to have around. Yeah, you can move on now.
So, real quick, FOMO, karaoke, it was really fucking fun.
Yeah.
Remember that.
Yeah.
Anything you take away from NixCon is this. Key information, Wi-Fi, figure that out. I think we're all good. Local leads, we did that. The most important thing you can do for us other than karaoke is filling in the survey. We really need that. It helps us, first of all, get a good understanding of who came in here, what went really well, and then secondly, what the hell to do next year. You know, karaoke-wise, only positive comments. I don't want to hear anything but that. Everything else, feel free to be yourself. That would be great. And with that, we're going to kick off. Oh, yeah, one sec. Quick show of hands. I don't know if there's slightly different people coming in for today. Who showed up today but didn't come yesterday, just out of curiosity? Okay, that's really interesting. Who has only been using Nix, not at all, or in the past year? Oof, I love that. Wow. Thank you, and Zach has a final note.
Yeah, so somebody, we found a pair of sunglasses at karaoke last night. So if you forgot sunglasses, like at 9 p.m. at a karaoke bar, come find me. Otherwise, I will donate them to a person in need. Cool. All right.
Awesome. Have a good day, too, and
Yeah, let's bring up our first speaker.
All right, I think we're in business. So, hi, I'm Z Yasso, and today I'm going to get to talk to you about one of my favorite things, Nix. Nix is many things, but my super hot take is that Nix is a better Docker image builder than Docker's image builder. As many of you know or have come to know, Nix is a tool that makes it easy to build packages based on descriptions using its little domain-specific language. For reasons which are an exercise to you, the listener, it is also called Nix. A Nix package can be just about anything, but usually you'll see it used to build custom software packages, your own Python tooling, an OS hard drive image, or Docker images. If you've never used it before, Nix is going to seem a little weird. It's going to feel like you're doing a lot of work up front, and at some level it is. When you're using Nix, you're actually doing a lot of the work up front that you would do in the future anyways. I'll get into more detail as this talk goes on. But who is this person, you might ask? I'm Z Yasso. I am the senior techno-philosopher at Fly.io, where I do developer relations. My friends and loved ones can attest that I have a slight tendency to blog a bit much, and I've been using Nix and NixOS across all my personal projects for like 4 years. I live in Ottawa over with my husband. It's all the morning, and I know we're waiting for that precious bean fluid to kick in. I got my Americano right there. Let's get the blood pumping with a little exercise. If you recognize my blog before, can you raise your hand? Oh, wow, that is way more than I thought. Okay. Raise your hand if you don't know what a Nix is. Okay. Raise your hand if you'd be willing to accuse yourself of being a NixOS or Nix or NixOS expert. Yeah, that's just about what I expected. And all right, you can lower your hands now. So, just to set expectations, this talk is a little bit more introductory than you might think. There's a mixed audience here. There's some hardcore users, there's some people who have never heard of this before, and there's a bunch of people in the middle. So, I want this talk to be a bridge between the complete beginner and the super expert so that we can understand what Nix is, why you should care, and where it is needed the most. If you're like a super expert, just keep in mind that this is going to show you how bad the state of the world is and where our powers are needed the most. Today I'm going to cover what Nix is, why I think it's better than Docker for making Docker images, and some of the neat second-order properties of Nix that make it so much more efficient in the long run. So, I said that Nix is a package manager, right? Well, it's kind of a bit more. It's a package manager, a language, and an operating system, and it's kind of a weird balance because it was named by computer scientists, so they named it all Nix. But you can use this handy diagram inspired by the Holy Trinity to split the differences. You use Nix the language to make Nix the package manager build packages, but these packages can be anything from individual bits of software, configuration files, to NixOS images. Of course, this is compounded by the difficulty of adopting Nix at work if you have anything but a brand new startup or a home lab where you're willing to tear everything down and reinvent it from scratch. Nix is really different than what most developers expect, and it makes it difficult to cram it into your existing CI/CD pipeline. I really don't think that this is sustainable, and I'm afraid if there's not a bridge like this, Nix will wilt and die due to a lack of adoption in the industry. So, I want to be that bridge today, and I want to show you to take advantage of Nix somewhere where it's desperately needed. Docker images. So, to say that Docker 1 would be one of the understatements of all time, my career started just about the time that Docker left public beta and you had to recompile your kernel in order to use it. And Docker containerization has gone from super niche to so widespread that I'd say it's the de facto universal package format for the internet. Modern platforms like Fly.io, Railway, or Render, they don't even bother doing anything but letting people run Docker images because it just works out better in the long run for everyone. And this gives people a lot of infrastructure superpowers. The advantages literally make the thing sell itself. It's popular for a reason. It solves real-world problems so elegantly compared to having to argue with your SRE or sysadmin team to get your packages updated in your local fork of Ubuntu because you want to use a library that's less than 2 years old. However, with Docker out of the box, there's just one fatal flaw. Docker builds are not deterministic, like not even slightly. Sure, if you go to the internet, you pull an average Docker file, you pull it, you build it, it'll probably work 99.99% of the time. That last 0.01% is where the real issues come into play. Speaking as a former wielder of the SRE shouting pager, that last 0.01 always comes into the factor at 4 a.m. Never while you're at work, always exactly at 4 a.m. Ask me how I know. One of the biggest problems that doesn't sound like a problem at first is the fact that Docker builds have access to the public internet. This is needed to download packages from the Ubuntu repositories, but it also means that when you're trying to go back and recreate an image at a later date, you can't just ask Ubuntu to roll back the repositories to what they were on that day. It's kind of annoying. And oh, remember, Ubuntu 18.04, it's going out of support this year. You're going to have a flag day finding out what depends on that version of Ubuntu with some CI pipeline breaks. Have fun. Even more fun, if you add packages to a Docker image the naive way, you get a lot of wasted space. If you run apt-get upgrade at the beginning of your Docker build, congratulations, you've just wasted several dozens of megabytes. Those extra files of the old versions will be shadow copies and wasted space, which will add up over time, especially with AWS and whatever, charging per millibyte of disk space and network access or whatever. So, if fetching things from the internet is kind of hacky and all of this other stuff, what if we had the ability to just know what we needed ahead of time so we could already pull it, have it cached, and get it cached a lot more durably worldwide? What if your builds didn't need an internet connection because everything was already downloaded and in the path for you before your build even started? This is the real advantage of Nix when you compare it to Docker builds. Nix lets you know exactly what you're depending on ahead of time and then can break it into as few Docker layers as possible. This means that pushing updates to your program means that only the things that actually changed have changed. You don't need to upload the entire Python interpreter again. You don't need to wait for apt or yum or npm or did not finish to copy things just so that you can change a single line of code in your service. And this is why I think this is one of the best ways to adopt Nix is to use it to build Docker images. This helps you bridge the gap so you can experiment with the tools you want to use while still having the tools that you have to use, without breaking your existing workflows. Asterisk. As an example, let's say I have a Go program that gives you quotes from, I don't know, Douglas Adams. I want to deploy that program to a platform that only takes Docker images like fly.io, Railway, or Google Cloud Functions. In order to do this, I need to do a few things. First, I need to take the program and put it into a Nix package, and then, make sure that it works or whatever. And then I need to turn that into a Docker image, upload it into my local Docker daemon, yeet it into the cloud, and then deploy it and hope it doesn't break. Here's what the package definition looks like in my project NixFlake. Let's break this down into some parts. This project is a Go module, so I'm going to use the build Go module template. This will set up everything you need. It'll set up your Go compiler, it'll set up a C compiler for C dependencies, and if you use anything beyond the standard library, it'll take a hash of the vendor folder of your dependencies. The name of the package is Douglas Adams quote in kebab case. The kebab case isn't required, I just think it looked better. The version is automatically generated earlier in the file and out of scope of this screenshot. And the source code is in the current working directory. And because I don't need anything other than the standard library in Go, because HTTP is server and client is in the standard library, I can just pass null here. If you need external dependencies, you should probably use a tool like gomod to Nix. I linked it in the description at the end of the talk. Now that we have a package definition, you can build it with nix build.hashbin. That makes Nix build the bin package in your Flake and put the result in /result. And as you see, you do nix build.hashbin, you run the command with --help. Let's pretend that actually tests the thing. And we look at it with file and see that it's an executable with some random garbage because that's how Nix makes things deterministic. So now that we have the package, we need to put it into a Docker image. And there's this neat family of helpers in the standard library called Docker tools. Docker tools is a bunch of wrappers that have different opinionated ways to put Nix packages into Docker images. There's two basic ways to use it. There's making a layered image and a non-layered image. A non-layered image is the simplest, easy way to do it. You basically take the program, all of its dependencies, any additional things like CA certificates, you put it in a folder in a single layer, and you push it up and pray. This does work, but it really doesn't let us take advantage of a lot of the unique properties of Nix. Making any change to a non-layered image means that you have to push all of the things that haven't changed. Nix knows what your dependencies are, so it should be able to take advantage of that when building a container image. Why should you have to upload new copies of glibc and Python over and over? It just doesn't make any sense. Nix also lets you make a layered image. A layered image puts every dependency into its own image layer so that you upload only the parts that have actually changed. Made an update to the WebP library to fix a trivial bounds checking vulnerability because nobody writes those in memory safe languages in Anno Dominium 2024? Yeah, the only thing that you need to update is the WebP library layer. It's great. The reason why this works is because there's a dirty hack at the core of Docker that nothing can take advantage of. Docker is actually a content-aware store, and the ordering of layers is added on in post. However, if you do this with the normal Docker build flow, you're never going to be able to take advantage of it because it just doesn't expose the right hooks to really use it. You know what does, though? Nix. A layered image means that every package is in its own layer, so glibc only needs to be uploaded once until we find yet another trivial memory safety vulnerability that's been ignored for my entire time on this planet. So we need to have a fire day rebuilding everything to cope. That's the best part. So here's what a layered Docker image build for that Douglas Adams quote service would look like. Again, let's break it down. You start by saying you want to build a layered image by calling the dockertools.buildLayeredImage function with the image name and tag, just like you would with Docker build. Now comes the fun part, drawing the rest of the owl. Except it's just one line, because we tell Nix that we want the resulting command to be running the Douglas Adams quote server, and everything will just be copied over for you, glibc and whatever it needs. I think it needs libgcc now, all time zone data, all of that copied over for you. You don't have to think about it. It's great. And in theory, if you need to add the CA certificate root, because Nix doesn't ship it in Docker images by default, you just add it to the contents, and in this case, I say contents has the CA cert package. My website uses this extensively to copy things like Dino, Typest, and the DAL tooling. So when you have this, you type in nixbuild.hashdocker and whack the enter key, and a shiny new image will show up in /result. Load it using docker load angle /result, and it'll be ready for deployment. So if you've never seen this before, this is a really neat tool called Dive. It is an interactive Docker image explorer that allows you to see the different layers of an image. And in this example video, I'm going through and going down on the left to the layers, and you see how each individual package is its own layer. It's going to go backwards and unconstruct the image right here. And it's so great. If you've never used Dive before, I really suggest checking it out because it'll tell you how bad you are at making Docker images. And so that's it. We've done it. And all that's left is to deploy it to the cloud and find out if we just broke prod. But it should be fine, right? So the really cool part about the layered image flow is that it will work for cases where you have one repository with one service. But that content-aware hackery, it does not stop at just one service. If you have multiple services in the same repository, they'll share Docker layers between each other for free without any extra configuration. I don't think you can really dream about doing this with normal Docker without making a bunch of common base images and hackery and pain and suffering and goat sacrifices. And we're running out of goats. As a practical example, I have a repo that I call X. It's my experimental mono repo where I have like a decade's worth of side projects, tools, experiments, and other things that help me explore technology. It's also a monorepo for a bunch of my other projects. Yeah, this is a lot of stuff. I don't expect any of you to read that, so I made it small enough so that it goes below the threshold for 2015 vision, so that none of you can read it. Don't read it. And most of this is deployed across like 4 platforms, and I've been slowly converging on deploying everything to Docker images just to have some shred of sanity left. But because it's all in the same repo, it's all in the same flake, everything shares stuff, I push updates to Mimi, I push updates to ZDN. It's magic. It saved me so much time and upload speed, and it's just so great. Take that, managed NAT gateway egress fees. Oh, wait. Do you hear that? I hear it too. It's the pedantry alert. Yeah, in theory, you really can do the same flow with Docker. You have to put, like, installing packages in different layers, and you can do it, but the problem is, it makes your build steps look like this. Like, sure, you can do it, but you can also write memory safe C. And installing all your libraries in separate layers invokes the wrath of general protection fault, and that's not somebody you want to meet at 4 a.m. Not to mention, you have to turn the network stack back on during builds, which means, oh wait, now your images aren't reproducible. Oops. You'd have to rejigger search paths, CGO flags, compiler flags, and goat sacrifices again. It's just a mess. But compared to that, just look at this. This is building a Docker image in like 4 lines, and one of them is in like 4 lines and a closing curly brace. That's it. It takes care of the details for you, so you don't need to think about what's going on. You don't need to copy glibc yourself. It just does it for you. I love it so much. But that deterministic reproducibility thing I've been harping on, yeah, we're going hard into it now. Nix gives you the ability to time travel effectively and build software as it was a year ago. This lets you recreate a Docker image at a future date when facts and circumstances demand, because you had one on-prem customer that was allergic to upgrading and they ran into a weird issue and now you need to recreate production from a year ago. So, in theory, when you're writing package builds with Nix today, you're taking from the time that you would have spent to recreate it in the future. You don't just build your software, though. When you make a package with Nix and Flakes, you are crystallizing a point in time where the entire state of the software universe converges to get your result. It is beautiful. As a more practical example, I've been working on a project called ZDN for a few years. It's my content distribution network backend. The name is an exercise for the listener. Here's how easy it is to build a version from 14 months ago. One command. That is the entire command. I say I want to build something from the GitHub repository z/x at an arbitrary commit hash and get the ZDN Docker target with a URL fragment. And then I wait for that to run, and I load it into my Docker daemon, and I get the same bytes that I had in 2023. Go 1.19 and all. This party trick isn't as easy to pull off with vanilla Docker builds unless you pay a lot for storage, have repository mirrors, and, more goat sacrifices. But the even cooler part is that when I hit enter on that build command on my local machine, I didn't actually build a thing, because Nix has the idea of caching outputs of previous builds so that you don't have to do it again in the future. A Nix cache is effectively a safe place to put the output of builds so that the builds don't need to be done. If you're building something locally with Nix, that's because it could not find the thing in the cache so that it could be lazy and not have to do it. So there's a popular Ruby library called Nokogiri, and every time it bumps, everybody's developer laptops have to go into like Mach 7 jet fans building the horrible XML parser every time it gets bumped by like 0.1 femto versions. With Nix, in the development environments, it would already be built for you, so you don't have to have your MacBook even like get warm. It's so great. This is the way to really use the power of the cloud to your advantage. In my experimental monorepo, I use a service called Garnix to do CI for my stuff, and on every commit, it builds it, It pushes the built stuff to a cache, and then my laptop could just download it. It's beautiful. I just push button, receive commit status reports. It's super great because I don't have to think about it, and it was literally zero config in my case. I even have all my home lab machines rigged up so that they're built with Garnix, so that when I push a change to my configuration repo, every night at like 7, 8 p.m., I don't remember how it changes because it's midnight UTC and daylight savings just happened. They pull a new version of their config, they pull the stuff from Garnix, they update themselves, sometimes they reboot, and it's just great. I don't have to think about it. Everything comes back up, asterisk. Not to mention, I don't ever have to wait for my custom variant of Yosevka to build, because building fonts is apparently RAM expensive on the order of 20 gigabytes. Why? I don't know. In conclusion, though, Nix is a better Docker image builder than Docker's image builder. Nix makes you specify the results, not the process that you use to get there. Building Docker images with Nix makes it easy to adopt Nix if you already use Docker. Nix makes Docker images that share layers between parts of your monorepo. And Nix lets you avoid building code that was built in the past thanks to binary caches. And in the end, you just get normal, ordinary container images that you can deploy anywhere, even big platforms like AWS, Google Cloud, or Fly.io. Before I get all this wrapped up, I want to thank everyone on this list for their input, feedback, and more to help make this talk shine. Thank you all so much. And thank you for watching. I've been Z Yasso, and I'm going to linger around out in the foyer, or whatever the word is in French. And if you have any questions, I'll be there. But if I miss you, I email dockerimage@zserve.us. That pings my phone and gives me a notification that I can't ignore until I reply to the email. If you want to help work with me at Fly.io, my team is hiring. Ask me for details, and catch up with me if you want stickers. I have some extra info linked at the Q. What? Oh, did I forget to push it? Guess who forgot to press git push before this thing? I was busy setting up my own camera and stuff. I'll do it live. Let's do it live. Okay, I can't actually see this. Okay, so when I say I can't see this, I mean I literally can't see this. Git commit -sm YOLO. Git pull rebase, or git stash, git pull rebase. Okay, it should be up in like a minute. Yeah, I can take questions. The question was, is there a practical limit to the number of layers in a Docker image? Yes, and that limit is 128, and it's dictated by the file system drivers that Docker uses. However, if you get over that limit, Nix will just take the least popular dependencies and make them buddy-buddy together, and it'll just squish multiple packages into a single layer. Otherwise, it will just, it will have the most popular things be in their own layer, so you don't have to upload glibc 50 billion times. Probably 10, but I wasn't trying to optimize it. If I really tried to optimize it, I would have it use an embedded TZ data and build with cgo enabled equals 0, so you don't have glibc. But realistically, glibc is going to be shared between all your projects, so it's effectively zero cost at that point. And having a libc is more convenient than not having a libc, even though nobody can write C safely. Does the build process of the image require root permissions? I I don't know what Nix requires. I think in theory you can do it with Nix rootlessly. You don't get the turning off the network stack side effect, but it would be able to mostly reproduce the thing. Yeah, I think it would work. Yes? If the Nix frame is installed as root, I believe if you're in the allowed users, it'll happen. If you're not in the allowed users, I don't know because I haven't actually used Nix in an environment where I'm not in the allowed users. You? Yeah, the question was, are you using Docker's image layer caching system and the ordering? The secret of Docker's image layer caching system is that the ordering is a lie that is just convenient to like do things. It doesn't actually need to exist that way. The layering is just a side effect of the implementation. The Nix works around it by creating the layers individually, and the ordering is really just arbitrary at some level. Yes? What is the minimum cache storage you need to build from 100 to 1,000 containers? I am not sure. I haven't built with that many zeros. I build 10 images, or 10 to 15 images most, and I don't have to pay for the storage, so I don't really think about it. You, back there. The question was what was the link between the cache and the determinism? Let me scroll back to one of my screenshots of my terminal here. I have a lot of slides. Okay, so you see this? You see that Nix store path next to interpreter there, where it's like /nix/store, and then a bunch of scary letters and numbers. Those scary letters and numbers are a hash of all of the inputs to the build, and that it forms the path for the output. It's not quite a content-aware store because it doesn't actually check what the bytes are because you can't really tell what the output is before you build it, and it will. Yeah, this is the inputs of all of that. Like, it assumes that things are deterministic, which they mostly are. There's some non-determinism that sneaks in because people embed the date that something was compiled, and as we all know, time is the ultimate in non-deterministic automata. But you can't link the wrong dynamic library, essentially. It's difficult to impossible, and this scheme does actually make your dynamic libraries effectively statically linked. Asterisk. Any more questions? That's it? Perfect. Thank you so much.
All right. We have a 5-minute break until the next talk. Real quick, if you lost a ring, I have it. If you'd like it back, you can bribe me.
Hello? So this is on now?
Yeah,
Okay.
no hot mic moments. All right, everybody, let's go ahead and get started with the next talk. So if you're standing, let's go ahead and take a seat. All righty. Do I have to be the teacher and make everybody be quiet? Whoa. All right, we're going to go ahead and get started. Everybody, please take a seat. If there's people around you standing, try to make room for them. I think there's a bunch of room at the back. Will, go ahead and take it away.
Hi. My name is Will Fancher, and today I'm going to talk about what NixOS calls Stage 1 and how we're using Systemd to improve it. Now, a lot of you might know me better as Elvis Jericho, which is how I go on GitHub and every other online platform. It's a little bit of a silly name. It's not like initials or anything like that. Bear with me, I promise this is relevant. So I have this name because when I was in middle school, I was trying to sign up for some online gaming service, and I tried this name and that name, and after a million tries, eventually the gaming service just gave me this suggestion and told me to use it, and I was like, okay, it's spelled a little weird, but whatever. So for a long time, I tried to keep it anonymous, where it was the name that only my friends knew, and only my friends knew that Elvis Jericho was Will. But eventually I started using it to contribute to open source, and that quickly dissolved. So nowadays, this name is effectively synonymous with me. And it highlights something that I've learned, which is that these very small decisions that we make can end up having very influential effects on our lives. And so that's what I want to talk about with Systemd Stage 1 and what we've done to bring that into NixOS. So first of all, what is Stage 1? It is a terminology that is pretty unique to NixOS. Most distributions and other products will call it something like initrd or initramfs, but we tend to prefer calling it Stage 1 because it refers better to the time period during boot that we want to talk about. Initrd or initramfs might better describe the particular file format that you're using to represent this concept. But with that out of the way, Stage 1 is the first user space code that the kernel calls once the kernel is started up. So when your bootloader gets going, it loads up your kernel, and it loads up a initrd archive, and then the kernel unpacks that into a memory file system and runs its init process as PID1. And its job is to find and prepare your operating system. We do this in a separate stage rather than in the bootloader because by harnessing the power of Linux, we can do drastically more complicated things with it. And that can include things like disk encryption or network systems or many other things. But the main job is to mount the root file system and other what I'll call core file systems. These refer to things like the Nix store or the etc directory that will populate with etc files and things like that are necessary to start the operating system. Once all of this is done, the operating system can start, and that means that we will find the init process for Stage 2, and we'll switch root to the new root file system and exec that as PID1. And now the actual operating system gets to start, and we leave the realm of Stage 1. Also, you do have to do NixOS activation, which, when that happens, depends on if you're using the old initrd versus the new initrd. We can talk about that later. So what we have right now is called scripted Stage 1. And it is effectively just this shell script and these options. This shell script is just this, I think it's a couple of hundred lines long or something like that. I think I just turned it off somehow. Can I be heard? Are we back? Hey, okay, cool. So, yeah. To future speakers, don't touch that particular switch. So this shell script is just, it is the sequence of steps that need to be taken by just about any installation of NixOS. And it is influenced by these other options. The first one, the file systems option, gets passed into the stage 1 script, and the stage 1 script will iterate over all of your file systems, particularly just the core ones, you know, Nix store, the root file system, and all of those. And it'll mount those, and this script has knowledge of how to do that best. So it knows which ones it needs to run a file system check on, or which ones that needs to be skipped. It knows which ones it needs to modify some of the parameters for. But the main job is to mount those file systems. But NixOS also has a lot of abstractions that get added into the initrd, things like LUKS encryption, networking, Clevis, and a variety of others. And these are always implemented in terms of these other 4 options. Things like pre-device commands, post-device commands, and all that. These are command or like little shell script fragments where you can assign to one of these options just a fragment of shell scripting, and that will get interpolated directly into a certain spot in this script file. And so the pre-device commands option, for instance, gets substituted into the script just before we start UDEV. The post-mount commands gets interpolated right after we've finished all the mounting, right? So these things all happen at specific points in time. So, but what is the problem? Well, it's one of those little things. You see, I found this one option in particular that bothered me quite a bit when I first saw it. It's this boot initrd LUKS devices pre-LVM option. And this one's really weird because what's happening is when you set up a NixOS system on an encrypted LUKS device, you have to tell NixOS, well, does that LUKS device get unlocked before we find LVM devices or after we find LVM devices? And that's just a little weird because it's a dependency that is, there's only one way to do it, right? One way to configure it. In theory, this could be arbitrarily complicated, right? You could have a LUKS device on an LVM device on a LUKS device on an LVM device and so on, as much as you wanted, and insert whatever complicated thing that you wanted in between. And this will not allow you to represent that, so you would have to do something custom. The other thing is that this whole thing is serial and imperative. It's just one big shell script that does one thing at a time, and it's all written in this very shell scripty kind of way. And probably the worst part is that it's all custom. There's a lot of custom code. So we have just hundreds of lines of shell scripting that just implements a lot of logic that is all done serially, and it's all a little codependent, and it's really awkward to maintain, and it's frustrating to write. So what about systemd? Well, so first of all, systemd is PID1 on an NixOS system. Its main job is to bring up your applications and your services. And it'll do so using what's called, or well, rather I should say, it manages the processes, the mount points, and the devices that can constitute a functioning system, which is to say, like, when you have NixOS running, it is keeping track of what processes are running, where your file systems are, what devices they depend on, and like how all of these things interact with each other. And it does so with a concept that is called units, which is a declarative concept. There's a lot of different types of units, but the 3 we're going to focus on are services, devices, and mounts. And a unit is just, it's a logical construct that exists in this graph, this dependency graph that says this unit depends on this unit, and this unit depends on that unit. And it allows you to specify things like arbitrary ordering, where you can say this one needs to be after this one, but I don't care how it relates to this other one over here. So this allows you to make very complicated logical graphs of how you want the system to start up. And what's important is that these things are declarative and they're parallel. So these things can start up whenever they're needed, as soon as they're needed. And you don't have to like write code that just says do this, then that, then this, then that. you get to put a unit exactly in the graph where it belongs, and systemd takes care of the execution. So if we put this in systemd, or in stage 1, sorry, it comes with a lot of configurations and tools included that we can use to drastically improve the way that stage 1 operates. Again, as I said, it is declarative, which means that we no longer have these large fragments of shell scripting that we have to just concatenate into another shell script. We just get to use declarative unit files that declare the dependencies, again with arbitrary ordering and complexity. It is parallel, which means that as the system is booting up, the things that need to start don't have to wait on each other for no reason. This can, in some cases, though in my experience not too much, improve the performance, the runtime that it takes to get through stage 1. It can make it a little faster. And it importantly comes with a lot of tools that we can use out of the box. We have so much custom shell scripting in the scripted stage 1 that we can replace with tools that come straight out of the systemd project that we don't have to develop and maintain ourselves. So I'll talk about a few of them now, and one of them, the first I'll talk about is the ability to use rescue and debug shells. So when the system goes into like a rescue or emergency mode during stage 1, you get dropped into a shell, and you get really useful tools like system control and journal control, which let you take a look at what's going on. What unit caused the system to fail to boot, and also you can look at like specific logs and really use the power of journal control to see what information you need out of the journal. This journal also survives to stage 2, which means that once you're in stage 2 and the system's booted up, you can take a look through what happened while it was booting up in a really fine-grained, detailed way. And then finally, if you are messing around in the shell and trying to fix what went wrong, like say something was wrong with the way the file system was mounted, you can mount it yourself and then just run systemctl default, which will cause it to retry the default transaction, and that'll cause it to just try to go to stage 2 again, and it'll go straight back into it. We also have systemd networkd. So in scripted stage 1, we have a scripted networking implementation, which is just the simplest possible network implementation, and it's extremely unreliable. With systemd, we are able to use the systemd networkd stack instead, which is very reliable. It also comes with a declarative method very similar to units that allows for these arbitrarily complex network configurations. And so far, this has seemed to be significantly more reliable and easier to work with, while also enabling significantly more sophisticated network configurations. And the thing that networking is useful for in stage 1 is that you might use it so that you can SSH into the stage 1 and unlock, say, your root disk remotely. So you don't have to be at the keyboard to enter the password to unlock your root drive if it's encrypted. Or you might have like a network file system, or you might do remote attestation to acquire keys, anything like that. Next, we have systemd ask password, which is a common protocol for allowing services to ask for a password that can be provided by some kind of response. The scripted initRD uses a number of unpleasant mechanisms where most of the time it's just asking for a password directly on the console, and then like if you SSH in or something, you can enter the password on some other means and then kill that process or something, or use this like weird bespoke command that someone developed in order to enter the password remotely. But with systemd ask password, the service asks for it using this systemd protocol, and then you can answer it in your SSH session, or you can let Plymouth, which is the graphical boot UI, implement its own systemd ask password response protocol, and then you just get graphical password responses for free. And all of this goes through the same interface, so no one has to do any kind of special work. Now, another thing that you can do with systemd that just comes out of the box is the TPM2 or FIDO2 or YubiKey integration. Systemd crypt setup, which is how you do LUKS encryption, supports these things out of the box. And all you have to do is use the systemd crypt enroll tool in order to set up the LUKS slot for it. The scripted stage 1 has some really complicated shellcode for dealing with YubiKeys, and it's very unpleasant to work with. So it's very nice to have these things as an alternative that just comes straight out of systemd. These also really complement UEFI Secure Boot quite nicely. NixOS has a project called Lanzaboot, which can do self-signed secure boot for NixOS, and combining that with things like the TPM can be very powerful. Now, I have an example here that I'm going to just explain how the setup works. Now, I don't really, you don't need to understand this, so it's going to get complicated and you don't need to worry about it. The point is just to show the kinds of things that you can do with this. So, on one of my servers, I have a root file system that is encrypted with ZFS native encryption. There's an asterisk there because I don't necessarily recommend ZFS encryption, but I'm using it because I can knock on wood. And this ZFS dataset is unlocked with a key file that is stored on a LUX volume. That LUX volume is actually stored on a zvol on the same pool. So you've got a virtual block device which exists in your ZFS pool, which contains a LUX volume that gets decrypted, and then that is used to decrypt the ZFS dataset. The LUX volume is unlocked with a combination of a TPM2 and a passphrase, which system decrypt setup supports out of the box. That passphrase is entered over SSH, so I can unlock it remotely. Over a Tailscale VPN, the SSH host keys and the Tailscale state are stored on another LUX volume, which is also on a zvol on the same pool, which is unlocked automatically by the TPM with no password required. And this is so that we can share the stage 2 Tailscale state and SSH host keys fairly securely while still requiring a passphrase for the root data set. So ultimately what we're accomplishing here is that we've got the TPM securing both the SSH and Tailscale credentials while still requiring me to enter a password to proceed the boot with the root file system, all protected by the TPM. And I've got a visualization here, if that helps at all. But yeah, you can see we've got the ZFS pool stores everything. You decrypt the SSH keys by the TPM, so that happens automatically. You enter a passphrase over SSH. That combines with the TPM to decrypt the root key to unlock the root data set. Again, I don't expect you to care about this. This is a really silly situation to find oneself in. But the point is that you can do these really complicated things, and systemd both has the tools to do these interesting things like TPMs, while also having the ability to specify these orderings and constraints against each other in a really elegant way. So now I want to talk a little bit about the roadmap that we have for using systemd in stage 1, because it is an alternate implementation of stage 1. So first of all, in 22.05, it was added with an experimental note in the documentation where all you have to do is enable this boot initrd systemd enable option, and that'll turn it on. So for a lot of systems, that's all you got to do, and that'll make it work. In 23.11, we removed that experimental documentation and called it stable. We think that this is going to work for the vast majority of people. So in 24.05, we would like to make it the default. There's going to be some minor incompatibilities, and in those cases, we will try to detect it and automatically fall back to scripted init RD. But we would really like to try and move this to being the default in NixOS. In 24.11, like I said, the scripted networking in particular is pretty unreliable, so we're planning on removing that particularly early, if we can. And then finally, 25.05, maybe. We'll see how the feedback goes. We would like to remove the scripted stage 1 altogether. And we being myself and a variety of other NixOS maintainers, most of whom are in the NixOS systemd matrix channel. So this is kind of the plan that we have for it. This is the timeline that we've been working on. So that you can tell this has been in the works since early 2022. Hello. Okay, that was weird. Sorry. So to conclude, really this is all about the small things, right? Stage 1 is realistically only a few seconds during boot. It's not relevant to the vast majority of your system's functioning. And really just one little option is what caught my interest and got me to start working on this. But in the end, it resulted in a massive collaboration between myself and so many other NixOS maintainers who I respect the crap out of. This little thing really led to a huge aspect of my history in open source. So if you take anything away from this talk, it should be, if there's a little thing that you're interested in with NixOS, whether it's a package that you want to contribute or a suggestion to documentation or one option that you particularly dislike, then you should go ahead and contribute because it can have a really big effect. Thank you. My name is Elvis Jericho. I saw you first. The vast majority of options, oh, sorry, thank you. So the question is about to what degree do we have compatibility? Will your existing NixOS config work if you just flip that switch that says systemd enable? And the vast majority of options relating to the stage 1 will work out of the box. There's a couple that won't. We know those ones, and they will automatically fall back to the scripted initrd if you need it. But so the main ones that will do that are things like those commands fragments that I mentioned at the beginning, like post-device commands, pre-LVM commands, those things. We have no intention of supporting those in the systemd stage 1. It's not exactly that we couldn't. We could create like a little synchronization unit, something that's like, it just runs that script fragment and orders that script fragment as a unit after all of these and before all of these. But really, that acts as a choke point that eliminates a lot of the benefits that we're going after here, right? It puts a choke point in the graph, it makes it less parallel, and also it preserves this imperative sequential style that we're trying to get rid of in the first place. So we think that it's better to instead just, when we see you're using that, throw a warning, say, hey, maybe try and figure out how to make this a systemd unit, and then fall back to scripted at stage 1.
So throw a warning, it'll fall back?
Yes, it'll fall back, yeah. Yeah, so that'll happen at eval time. So the question is, do we have some way to make smaller unit files? And I'm not sure I quite understand the problem. I see. So the question is, yeah, if we wanted to take what we're using to create units for stage 1 and use that in some kind of other context, I think. Is that about what you're asking? Yeah, that I don't think really exists at the moment. I've heard of people trying to make things like that. I don't think it would really be anything to do with stage 1 in particular, but like I've heard of people trying to make it so that like you can use the systemd APIs that NixOS has in order to manage systemd units on like Ubuntu or whatever. So that exists. It's definitely not like upstream in Nix packages though. Okay, so the question is about Bcachefs support, in particular with multi-device, and did you say encrypted? Yeah, multi-device and encrypted Bcachefs file systems. That is a tricky subject. The big problem there is that there isn't really a good implementation of within systemd for this sort of thing. The problem is that, like, the best way to import or to mount your bcachefs file system is with uuid equals yada yada yada, right? And that works great if you specifically use the mount.bcachefs helper command. But if you're trying to do anything abstract, it immediately gets torn apart because the like util Linux or even systemd, all of these things will see that uuid equals blah 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 and tear it down into an actual path, dev disk by uuid, all this stuff. And bcachefs doesn't like that. So there's a bit of a mismatch between how bcachefs is trying to do this and how everything else in the Linux ecosystem is trying to do this. And it's really hard to figure out how to fix that. So the alternative is that you can instead specify things by devices separated by colons yourself, but even that gets a little tricky because now systemd sees, oh, this begins with /dev, and it tries to wait on that specific device, but that device is one with a colon in its name that is then followed by other stuff that it doesn't realize are just more devices. So systemd just doesn't have a good way to do this. The reason it works in scripted stage 1 right now at all is basically luck. And it's really it's a tough situation, and there's a lot of theorizing going into how to fix that, but there isn't an answer at the moment now. It would be really good to have some way to detect that. We don't have that yet, but that's something I would like to look into. However, I will note bcachefs is an experimental file system, so I'm not going to feel too bad if we don't have the best support for it. Go ahead.
Is it at all desirable to move away from the custom switch root step that we currently have, where we also do the NixOS activation and use whatever systemd?
So he's asking about the step that we do at the very end of the scripted stage 1 where we do a switch root. And so the way that we do this in scripted stage 1 is we literally just run switch root, which automatically changes the root file system of PID1 to the new one, the real operating system's root. And then the way it happens when you're using scripted stage 1 is it runs your NixOS activation immediately as PID1. We had to change that up a little bit with systemd because there's one thing that we really want to be able to do here. Systemd can serialize all of its state, all of its knowledge about units and stuff, and pass that along in a file descriptor to the stage 2 systemd. We really want to keep that, but it doesn't do that if PID1 in stage 2 isn't literally the systemd binary. So what we have to do is run activation in a CH root as a unit within stage 1 in the systemd stage 1. So that's how we're doing it right now. And the benefit is that we get much better insight through tools like systemd analyze as to what was going on during stage 1. But yeah, we did have to do that a little differently. Okay, thank you very much.
All right. Thank you, Will. We'll take a couple-minute break, and then we'll have our next talk.
Sure. So, in your trivial example, or non-trivial example,
Yeah, non-trivial for sure.
All right, folks. Let's go ahead and get the next talk started. So please take a seat if you're milling about. All right, let's go ahead and start the next talk. Take it away.
So, everyone hears me, I think so. Perfect. All right. Louder? Okay. I can try. So, hello everyone. Thank you for having me today. My name is Pierre Pennings, and I'll be talking about how we can make NixOS easier for self-hosting by using module contracts. So first, a little bit about me. My handle is Ibizaman. Thank you, Will, by the way, for giving me a reason so that I don't need to explain where it comes from. So I find myself as a self-hosting and data sovereignty advocate. At Fastly, I work as a staff engineer on the next generation web application firewall product. By the way, there's a cool fast forward program for open source at Fastly. And fun fact, actually, I learned while I worked there, where the CDN for the Nix packages binary cache. Sorry. I mean, thank you. So before starting, we need to go a little bit and follow my adventures using Linux. So it all started in 2008 when I switched from Windows to Ubuntu. You know, Windows was the desktop computer at home, and I saw this on the internet, like Compiz. I saw cool stuff, things you could do on the desktop, and I absolutely wanted that. So I forced everyone to switch to Ubuntu. But then I kind of really liked Aptitude. I don't know if you know that program, but it's essentially a catalog of all the packages you can install. And I literally spent hours browsing through all the descriptions, reading everything, trying things out. And for me, that was really fun, you know. So my big takeaways for this part of my journey was, I like when things look good, and also a catalog is really something I like and I want to find out. But then at some point I went deeper. I wanted to learn more about Linux, and the thing is, sometimes I had issues understanding exactly the issue was when I encountered the problem in Ubuntu. Like, the documentation is really good, but it still has this layer of magic on top where sometimes it hides too much. So I switched to Arch Linux mainly because I was reading the wiki and the documentation is pretty good and I could do everything essentially without needing to talk to another human, which is good sometimes. But my big takeaway for that is, yes, it allows onboarding and self-service if you have good documentation. Then some while later, you know, I had this Arch Linux box at home and I installed a lot of things on that thing. Like I was trying everything I could, but it was just too much. Like I was doing imperative, you know, going SSHing in and trying to tweak everything. And when I upgraded the box, I forgot what I did, and it was just a mess. So at some point, I figured out, hey, there's this Emacs thing I'm using to edit things, and everybody knows Emacs is not just an editor; it's also a full operating system. So I was like, hey, shouldn't we use an operating system to configure an operating system? And I was like, sure, let's do that. So I used all the features I could find of Emacs to, well, look at this. It's essentially an interactive checklist of things I needed to do to install a service on my box. So you see at the top, there's variables. Some comes from a secret store. And then you have multiple steps of things I needed to do. So just example, okay, perfect, you can read it. So yes, there's an install step here. There's a step to create a Postgres user. There's a step to generate a file that gets copied over to the server, to configure the reverse proxy. And then I wanted to add Keycloak in there to have a single sign-on at home. I mean, I'm crazy, I guess, but that was pretty cool. And I tried to do that, but I needed to shell out to bash scripts because it just became too complicated. And this thing, I mean, I know what you're thinking, but it worked. I was very proud of how it worked. But I came to this, like, this is like the top level, you know, of everything I installed, and it just piled on. And at some point, I was just copy-pasting everything all over the place. And it became, again, unmanageable. I was doing software work, on the side. I mean, I guess to pay the bills, so it's not really on the side. This is on the side. But I was using there a real programming language, and you have functions in there, and that's essentially what I was missing. But the other thing I kind of figured later, going through all this and then essentially preparing this talk, is that what I was missing also is this one source of truth we have in Nix. Because on my machine I was doing stuff, and then I had this file, and then state drift apart. Like literally two days after I started all this, things drifted apart, and it was very hard to maintain. And so I kind of knew about this Nix stuff, so I wanted to try it out. So yeah, I have these beautiful lines. I mean, remember, I like things that look good. And this services.nixcloud.enable equal true installs Nixcloud on my machine. Like, remember, like the things I had before that I needed to do, and now I can do just this. This enables Nginx for you. It sets up PHP, PHP FPM. It sets up Postgres, and it even can let you choose between multiple databases that you want to set up. And it also allows you to choose between the different caches you want. So I was just hooked up, like since the moment I saw that, I thought, okay, I need to use Nix for everything now. And also, if you remember all my takeaways, like it checks all the boxes. Like it has good looks, obviously. It has a catalog. And by the way, I learned yesterday about the Nix search thing, so I will definitely use that. It has, honestly, I think it has good documentations. We all joke about it, and I think it's not perfect also, but most of the things I wanted to do could be done without talking to another human, which again, it's a good thing, I guess, for onboarding and self-service again. And it's obviously a programming language, and it handles the one source of truth pretty strictly, I think we can say, but I guess it's for the best. But then that's when the honeymoon stopped a bit. If you remember, I mean, I don't know if you remember from the slides I just went through, but I was using HA proxy as the reverse proxy for Nextcloud on my box at the time. And I wanted to switch over, like gradually to NixOS. But then I hit a wall where inside the Nextcloud module, everything is hard-coded for Nginx. And you cannot really choose another reverse proxy. And actually, if you go in the wiki, it tells you, yeah, you can definitely use something else, but just do make force disable Nginx, and then you're on your own. So coming to Nix, that was not a good experience, And so yes, over reverse proxy, I was using HA proxy, but what about Caddy, traffic, etc.? And another thing, a random thing I noticed that we hardcode pretty much everywhere is path to SSL certificates. I don't exactly know the reason why, but we always kind of hardcode /var/lib/ I forgot now exactly where those lives. But coming from the software world, I felt like this should just be a variable, And then I guess the thing that really bothers me the most is that, like I was saying before, you can choose in the Nextcloud module, which database you want to pick, which cache you want to use, but that work is all done inside that Nextcloud module, and there's no way to reuse that. And I thought to myself, well, that's kind of a wasted work, in a way. Like, it would be cool to extract that. And so this is how I picture the situation in my brain. You have, and by the way, I'm talking about the Nextcloud module just because that's the one I know the most. I know it does a lot of things. I'm definitely not picking on it. To the contrary, I would want the work that's being done in there to be helpful for other people. And so, again, this is how I picture the situation. There's this core module in the middle of the Nextcloud module service, and then you have auxiliary stuff, right? You have, but the thing to realize is, to me, you have a lot of implicit contracts in there. If I just take one example, say you set up MySQL, or I mean, you select to set up MySQL. Well, the thing is, how the Nextcloud maintainers set up MySQL is how they want the core to be able to use MySQL. There's like, they set this up in a very specific way so that the core can use it in the way that the core expects. And that's completely implicit. Maybe there's a comment somewhere in the file, but that's essentially, that was in the brain of the maintainers, how they set it up to pass the test and everything. But it's, in a way, all gone as soon as it's pushed on GitHub, and you don't have that context anymore. So what I would love the community, actually, in general, to go towards to is to get all these contracts out of there in something like the documentation, or maybe something better than that, but as a first step, I feel like we should have this NixCloud module be mostly the core thing. And then it would branch out to those, what I called contracts, which would be, say, let's take the example for the reverse proxy. This would show a few options that you can pick and choose for the core to use. And then on the other side, you would have the Nginx implementers knowing, hey, when people set these options in the contract, I know that my reverse proxy must work this way. And so think of it as a splitting the concerns here. And the natural extension of that is that, well, other people can then add more implementations for these contracts completely independently of what the maintainers of NixCloud are doing. And you could even do that on your own machine. I mean, I should not encourage that, but I meant not upstreaming that to Nix packages. But you know, if you have things in your company that cannot be upstreamed, well, you can still do that and plug and play inside that NixCloud module, for example. And how I picture this separation of concerns is now you have multiple people in the loop. You have the maintainers of NixCloud that uses this contract, this abstraction on top of modules that exist. You have all the different maintainers of all these implementations that made work to respect this contract. And then you have, for self-hosting, very important, but I feel like for pretty much everything we do, there's this end user that now have the choice to pick whatever implementation they want to implement this reverse proxy thing that NixCloud is depending on. And that's, to me, very powerful. And something we don't really have now, or at least it's hard-coded, like I was saying, in various packages here and there. And then for this reverse proxy, at some point, there needs to be talks, right, on exactly how this interface must behave and everything. But I'm getting a little bit ahead of myself here. The good thing, the good news, is that this contracts already exist kind of in Nix packages. If you take like the .enable option, it's pretty much everywhere. Like when you have a service, everybody knows that, everybody expects these options to exist already, but also everybody knows how this option should behave without even reading the documentation. You know that if you have a service that has .enable, you set it to true, then this service will start next time you do the NixOS activation. If you set it to false, then it won't, or it probably won't even be pushed on the box. And then on the other side, everyone that implements a service knows that this option is expected, and that if it's set to true, they should do whatever is needed to start the service, and if it's false, they don't need to do anything, essentially. But that's, to me, a contract. It's nearly an explicit contract, but it's more a convention, I guess, than something that's explicitly stated that a service should have a .enable option somewhere in the documentation. And that's where I would like to introduce my project. It's called Self-Host Blocks. It's a name. And the whole reason of this project is to be a proving ground for contracts. It kind of didn't start that way, but it became that. But the one thing I found cool is NixOS VM test, and I used that to enforce those contracts. And it implements a bunch of things. A lot of things are work in progress, to be honest. But I actually used that on my own server, so I think there's another person that uses that, so we're two. And to finish up, I'd like to show you an example of what a contract looks like and how it's used inside that project and why I think that's super valuable. So let's take the SSL certificate generator contract. This is the contract. You have 7 options. They have types, documentation, and everything, but I'll go through that with examples. So to see exactly the point I want to make, we need to take 2 examples. First, what happens when we generate a self-signed certificate and we want to use that? And then second, just after that, I'll show you how that works with Let's Encrypt, okay? So first, the self-signed one. You have this block here, there's options you need to set up. You need a certificate of authority. I won't go into detail how you get that, but let's say you get it. And then you set the domain and extra domain options to generate the certificate for these domains. Now let's switch on the generating for Let's Encrypt. Kind of similar. You set specific options for Let's Encrypt. And then you have, again, the domain and extra domains you want. But now, let's see how it's used. Okay? And spoiler, that's what I've been building up since the beginning of the talk. So this is where it happens. And remember how there were those multiple peoples all interacting together. So there was that end user, selecting which implementation. Well, this is represented here in that Latin block. The user here chose the self-signed certificate, okay? And it's inside that cert variable. And what's going to appear inside that in block is what the NixCloud, say, maintainers will be using, and they will receive that as an option for the module system. So here, it's just setting up Nginx VirtualBox, and you see it uses the path.cert and path.key option that they know exist because of the contract, and they would set it up as a SSL certificate. They would set the group that the keys should have, when they created the Schmod group, so that they know that Nginx will be able to read those keys. They would add which services need to be reloaded whenever the certificates get regenerated, here, say, every 3 months or something. And then, oh, yeah, right. So the question was, is this work already happening inside Nix packages, or is it essentially conventions that emerged? And would it be solidifying what already exists, or kind of new work? So I don't know, actually, to be honest, if something like that already exists. The community is so vast, and things happen in so many spaces. I didn't find anything that does this, but these are the ones I found. And I think those emerged by convention and people just, copy-pasting or copying on what works in other modules. And it kind of is now a convention. But yes, the goal of this would be to have more thought about other domains of, again, I was thinking for my server, self-hosting, but maybe other aspects I'm not thinking of, like maybe some more codification of these domains and how we can make them reused in the space. And you had a question too? Yes? So the question was, or I guess more a statement. Yes, you're sure that the Kubernetes folks did a lot of work that resembles that. For example, you have an interface that multiple reverse proxy implements. And to be honest, I'm not that familiar with Kubernetes, but that really sounds like the same thing indeed. So yes, we could probably learn a trick or two from there. Yes? So the question was kind of what happens when you scale this out for the SSL generate certificate example. Well, to be honest, this is a really small scale for now. It's on my own box, and then, like I said, on one other people's box elsewhere on the internet. So I didn't hit that yet, nor any kind of using Nix at scale. So I'm sorry, I wouldn't be able to really answer on how to do it the best way. Yes? Yes, that's actually a good question. I did it in a way in that project, but I'm not sure I really like it. The way I did that it's to have a common library of options. And for example, you have for this generate certificate, this contract, you have essentially an attribute set inside that library with all the options. And when you say, for example, the NixCloud module says, hey, I want you to give me something that implements that contract, it just reuses that whole block of options and put it there as an option inside that module. It works. I'm not sure if it's the best way to do that, though. All right, thank you very much, everyone.
All right. We now have a short break. We'll meet back here at 11:30, and my coworker Tom will tell us about remote builders and substitutors. So I'll see you back here in about half an hour.
Test, test, test. Test, test, test.
Should be off. Should be off. Should be off. Good, good, good. Hello again. Hello. Is it? No. Good. Yeah. Whatever happens. Okay. How's life? Good. That's all I got. A few minutes. 11:30, I believe. Did you yell at people? people probably left for lunch too.
Yeah.
Man, we hungry. No problem. It's a little bit of a filler anyway. But that works.
Right, folks, we're going to go ahead and get started with the next couple of talks, and after that, we will break for lunch. So first up is Tom, and he's going to talk about remote builders and substituters. So give it up for Tom, and take it away.
All right, test, test. All right, hi everyone. Thank you for coming. I'm Tom. You might know me as Tom Barek. I work over at Phlox, doing some wild, crazy things, hopefully. And I was trying to figure out, I'm a Nix user for about 10 years now, I think, at least. I think I looked at Nix packages, so approaching 10, 11. I've been doing various efforts in different parts of the ecosystem, either in Nix packages or just maintaining things, trying to market it, trying to spread the good word. So at some point I'll say I'm a fanatic, but in general, if it's related to Nix, I am happy to talk about it at length. So yeah, let's get started. One thing I want to talk about is today and yesterday we were kind of doing a lot of introductions, a lot of brand new concepts, and trying to teach people. Here today I want to introduce. You probably can't get all the way to the point of having everyone kind of using all these advanced topics very early, but I want to kind of explain a little bit of why. These are some of the things that are really interesting and cool, some of the superpowers that people might want to leverage, and just knowing they exist is something I want to get out of this. Obviously, these can be complex details, complex topics, and you might need more work. All right, so yesterday we talked about like the cliff of learning, and you know, there's all this stuff about like you gotta learn the language, you gotta learn how to like build environments, what are flakes, what's the ecosystem, what is a package. And usually once you kind of get past that cliff, all of a sudden I think there are these like huge benefits. And two that I really love are the fact that we have substituters and that we have remote builders. So I wanted to just talk about them and introduce them. Yep. So first we have to start with some concepts. I apologize, you know, we have to kind of do some definitional things just to make sure we kind of have a core. Copied most of these things out of the manual. That has actually improved greatly these days. So if you take a look at the glossary, take a look at the definitions, things are in there. So what is the store, right? The store, often we think about this as, oh, this is just, you know, in my machine, you know, Nix/store. Great, that's kind of where the files go, that's where they are. And that is one instantiation of it, probably the most common one you'll see, the one you're familiar with. But there's a notion of a store that's a bit more abstract, that's just, well, it's a place where you have data that's immutable, and it can have references to other pieces of data. And the system will keep track of those references so that if you need one piece of this immutable data, let's say you move it around or you copy it somewhere or you need to like leverage it in some way, those references are tracked and remembered, and therefore you can kind of move that entire thing from one place to another. And there's a sense of integrity that this store has, more than just here's a key value store, right? So these cross-links, these cross-references are kept track of. And there's multiple types of stores. So if you kind of, as you start working more with this, you'll start to see a few more. You might have encountered so far something like HTTP stores, right? This is, if you go look at a cache, you'll encounter other types. So we'll go through some of those, but just understand that these other types come with different capabilities. Sometimes it's similar to what you have locally, sometimes it's different. Now you have a substitutor. Usually the way this works is that you are working locally, you want to either build something or copy something or use something, and as an optimization what we do is we say, hey, let's go find it somewhere else. And that way I don't have to build it, I don't have to do something that takes a long time. And any of the stores can actually serve as substitutors. That's a pretty powerful concept because now this one object can be used in several different ways. And then lastly, what is remote building? Well, I don't know, I have a small laptop or I have different types of machines at different places. I want to go build on them. I want to distribute work. Distributing work is a really powerful idea. The more you can do that, the better. And Nix, because it kind of saves all this information about how to build something, what it takes, all that really good bookkeeping, means now we can distribute work in a really reliable, productive way. So how can we leverage this stuff? So to learn more about this, I'm just going to put some references up here so you can get started to figure out what these are. But you can go look at the help for the stores. You can kind of see what operations the store layer allows you to do. There's a reference manual for this thing. So let me see if I can move this over. That lists various kinds of store types. It shows kind of how you can use them. They're described in this URI format. It's a little bit clunky. Ideal, you could have a bit more of a structured way to talk about all the different parameters and the options you have available to you. But for the moment, it's this kind of in the query syntax URI thing. But it does what it does. So there's some documentation for that to look at. So you go look at the various kinds of stores. The most first one to talk about is just the automatic one, the thing that you kind of get when you're using Nix and you're not really worried about this thing. Auto will do basically the right thing. If you have different kinds of a multi-user install, you have a daemon, it'll connect through the socket. If not, it'll talk directly to your local file system, or it'll do things where it'll talk to either something that's bind mounted somewhere. But the point being, auto is usually what you're just always using, and it kind of does the right thing. But we have other stores, there's local one is kind of very specific that says, no, use the local thing, don't be too smart. Or there's a dummy one that basically just doesn't do anything and it supports a very limited set of operations. So if you want to, let's say, just run some Nix evaluations of some expression, but you're not interacting with the store in any way, you're not putting new files in or you're not building anything, you're just kind of evaluating some sort of thing, then dummy store is kind of a fast way, a way to not even require there to even be for you to have one. Some other common one would be one that's on a remote machine, so via SSH, right? We like to do remote things with that. Another common one is S3. This is kind of where we often put things as well. And so you can kind of see some examples here of how you have other parameters and how you kind of include those options in there. Not the most, again, not the most ergonomic. That needs a little bit of work. Now, some of these stores have different capabilities. Your local store, right, obviously can build stuff. Some of these you can't, right? You can't really just say, hey, I want to go build something in cache-nixos.org. Doesn't quite work. That would be mayhem if we did allow for something like that. And also, binary caches have a different goal. They're optimized to do something different. So that's an outcome of that. All right, let's go a little bit more into remote builders. So this will work with any store that can do building. There's a list of those. Usually, it's going to be something like over SSH. That's kind of where it goes. There's going to be a manual for this. If you want to kind of take a look at where this goes, here's what that manual kind of looks like. It introduces the idea. It talks about how to test this out, configure it. It kind of goes through some of the formats. It kind of gives some examples, but kind of take that and see if that's helpful to you. It's located at that URL. So let's say you have some remote machine. Let's say I'm on my Linux machine and I want to see if there's something on my Mac that I want to either build or push builds over there. So you can kind of start to test this out. There's command line arguments and command line commands that lets you kind of test this out. You can also configure it that way so when you want to do something dynamically, that's available. So you can see here we're talking about a store, hey, SSH, ://Mac, right? So assuming I've got all my resolution and host names figured out and assuming we've got authentication and SSH connections are all working, all the things are working, cool. This thing will say, hey, thanks, the store exists. Here's a little bit of information about it, proceed with life. Or it'll give you some errors. This is a common place where I think people get stuck trying to use this feature set. So yes, I'm just going to acknowledge this starts to get towards the advanced side where you can kind of figure out why did it not work. What, is it that SSH isn't working? Is it because the host key is not trusted? Is it because your daemon doesn't have access but your user does? Like there's all sorts of like weird little quirks here. Yes, it's hard. I'm just going to simply acknowledge that. Where does the configuration for this go? So one common place you can put this configuration is in etc NixConf with all your other like system level configurations, and you can kind of just use this format in there to specify a bunch of builders. You could do, basically what you say is, hey, here's how you get to this store. That's that URI for the format I'm kind of putting out there. Here's the system or systems that thing can support. So let's say, it's a way to advertise and say, well, I'm going to distribute this particular kind of a system to that particular machine. You specify usually some sort of a credential via SSH files, number of jobs, also a factor of like how fast that machine is and how to kind of weigh between different machines when you're distributing. There's features, supported features, required features. You could put in a public key so that that whole problem with having like a host key not known is kind of resolved. A lot of these are actually optional. In fact, pretty much everything other than the first parameter, which is URI, is all optional. Again, if you go look through the documentation, it talks about what they are. Easy to mess up here as well. Again, got to read the documentation very clearly. Like a common one that I ran into is like your public key. It's got to be this base 64 format of your SSH fingerprint. Another common mistake, your daemon user has to be the one it's the one that mediates this. So if you're on a NixOS machine or you're a multi-user install, you got to kind of make sure that your daemon actually can do this. One pro tip, builders use substitutes as a configuration option. What this means is that it allows all your remote builders to directly substitute by themselves without you having to push them. It cuts down on some of the network transfer things in some cases. But usually highly recommended. Why do we do this? We like to use more machines and distribute stuff because sometimes one machine just isn't enough, just doesn't cut it. And we like speed. All right. So other reasons we might want to use this. We have, let's say, different systems, right? I have one machine with one architecture, but let's say I have to develop and provide support for more architectures. Well, I want to be able to build for them. I want to be able to test, make sure those builds work. Yes, I could push it to CI, but that's painful and annoying, and you push, and then you try again because you made a mistake, and you got to wait 10 minutes, and you push it again, and got to wait for the jobs to get picked up by your runners. Like, no, what if I just say, I want to run a bunch of builds on all my remote machines, already set, go, right? Instant feedback, faster development speed. And then when you know what you're doing, those things are all cached nicely, and you can start like pushing things with a bit more confidence. Remote builders are good because it makes things faster, right? If I want to do a large number of builds and they can be split into like smaller chunks and I can distribute them, hey, that's awesome, right? Big build graphs, something that's brand new, let's say change something very core in some sort of dependency. I'll need to do, 100 builds. Well, let's start doing them in parallel. Why not? Another example is you have a slow local machine, or let's say your local machine doesn't have really good network access, but you have kind of SSH access to something that is way faster, that's better located closer to your caches or closer to the internet backbone. And so here's kind of how I sometimes use it. I literally just say, hey, I'm working on something. Hey, I want to build out of my default package, but I want to build it with some combination of things. Usually this is like the kind of the 2x2 combination of things I'll build just to kind of make sure everything works. It's nice. It's simple. When it works. That's the problem. All right, so I'll try to do a demo of this, and let's see how far we can get. And that is way small. And we'll see if it works. So basically what we're doing here is I just kind of made up a random derivation, and said, it's going to be of those 4 different system types, right? So we got x86, we got Darwin, we got Linux, we got Arch64. And my machine is not necessarily configured to do those builds locally. I don't have anything special set up to kind of handle them. And so instead, what's really nice is I say, hey, I have these 3 other machines set up. They're connected via a SCaLE network, and I got all the keys and configuration has been done. And those 4 builds got distributed out to those places, and whatever, they're really simple builds, so they actually happen really fast. They got done, and they got transferred back to my machine. All that transferring, for example, of like the builds instructions, the results back to me, right? This is all depending on these invariants of the store, right? The store keeps tracks of references. It keeps track of what that data is. It keeps track of the signatures that might be on these things. So all of that is kind of handled for you, and then you just kind of get to reap the benefits. So that's kind of nice. I don't know. Actually, this might be a good spot to stop and just say, with what we've seen so far, are there any questions? Yes. So the question is, when is it necessary to stipulate auto? That's a good point. I think it's just so that, let's say you're trying to like template some command, and there's a default that just works and does what the default is, right? If there was no name for the default, you would never be able to specify it, basically. Otherwise, you'd have to admit it, which is like now a conditional of some kind. I think next was you, sir. Yeah. So SSH-NG is going to be, it stands for next generation, right? It is a different protocol than you originally had with just SSH, where you're kind of talking what's called the daemon protocol. It's basically it's turning into the default because it's kind of in all respects better. There's a few slight differences, but generally, if you're going to be doing this by default, you should just be using the SSH-NG. We could go into details, but I think it might be too much. Oh, the question was the difference between SSH and SSH-NG. Sir. Yeah, so this is for remote building, and oh, sorry. So the question was, hey, I have 100 engineers, and I want to be able to do like load balancing. Can we do this via HTTP? So the remote builders are basically, it's just one kind of a subset of store types. Now we can't do builds on an HTTP store because, well, you know, just usually the HTTP doesn't really support that mechanism to kind of send things back and forth, or we haven't implemented, you know, hey, you do a put request and here's how it gets interpreted and all that. But what you can do is say, use something like SSH to run the builds, but then to get the product of the builds, the outcome of the builds, that comes back to you via HTTP. So I think what you might be thinking about is a substitutor, and we're going to cover that in a second in a little bit more detail. I don't know if that answered your question, though. I see. Okay. So to have a remote build farm. So some of the abstractions that would be really nice for the remote system is to be able to kind of load balance and say, here's like one kind of proxy, which is going to proxy for the other 100 builders. We don't have that yet. Right now, you kind of have to have each of your engineers list all of them. Let's say there's 100 machines. You can maybe update that file automatically. I'll show you kind of how you could do that. But that one feature you're talking about, I actually want that too, which is to say, here's your one proxy, and it will keep track of all the machines, and it's going to have access to everything. And then that way the end users only have to do like a one-line config, not 100-line of all the machines, keeping track of it and maintaining it. But work in progress. So. Not that I'm aware of. So the question was, does that supported today? No, I think there's ways you can kind of hack it if you really dig into it, but basically no. Yes. Yes. So, yeah, the comment is nixbuild.net works that way, right? So there's a way with what's the Nix remote, configuration allows you to kind of hook into this system and do custom things. You kind of have to know what you're doing. Nixbuild.net has kind of hooked into that mechanism. There's a few other people that have tried to do various kinds of scheduling efforts to make that effective. So you can do it, but again, you have to know what you're doing. You have to have explicit support for it. And, well, we just got to kind of document this better as well. A lot of this is not as well described as it should be. Sir. So the dummy would be something where, let's say, you are only trying to do some large evaluation of something, but you're not trying to build anything. So let's say you need to evaluate, I don't know, some expression, or for testing purposes, you want to just test something. That's basically why we implemented it, was because you want to test some things quickly for, like, do all these expressions evaluate to the same thing? You don't need a store for that. You're just trying to test the language and evaluation layer. You're not testing the store layer. Most people probably don't need to know about it, but it's just interesting that there's one there that's just the dummy that has no store capabilities. It's just kind of blank. Yeah. Yeah. So the question is, the Nix store has a database component that keeps track of a bunch of metadata. Is that required for the store? The answer is yes. For at least the local file system store, that database is what keeps track of a lot of these things that you need. You could remove that database and all your software will still work, but any Nix operations will not work so well. Yeah. Okay. I'm going to try to proceed a little bit then. And luckily the demo worked. I'm super happy about that. Okay, so we kind of covered some of these things. Nothing to notice. Authentication is an issue. I'm just going to kind of gloss over it, but I'm acknowledging that that's a problem you will encounter. I guarantee it. Next issue you'll encounter is signing. Once you start pushing binary blobs around, you want to sign things, and you want to make sure there's a way to accomplish this stuff. There's a mechanism for that. Again, this is in there. You sign things with these keys. You can create the keys. You can push them around. There's a standard one that cache NixOS org uses, and during the default install, basically you're all saying you trust the NixOS Foundation to run this and not send you malicious code. That's like the core trust mechanism that does that. If you are implementing this in a company or in some organization, then you probably need to get more interested in how the signing process works. Binary caches, easiest way to get started, honestly, is just the S3 one. If your user has the credentials for it, you can copy things into it. You just say, hey, I want to push things to some bucket, ready, set, go. If you want to get involved in signing, here's some of the ways to get started. You just say, hey, I want to generate a secret. I want to convert it also to a public key, so kind of have both sides of that key pair, and like sign things. One big issue, it looks really small, is that little tack R on the signing. That says you want to sign all the things down your closure, not just that one store path. Common mistake. But you can verify things, there's operations you can do all this, but we want to be able to save our work. All right, substitutors under the hood. Here's how they're actually put. And here there's no database. The metadata of what depends on what is actually in these files called nar infos. Your actual data is put into those nar compressed files. So let's actually take a look at one of these nar infos. The way this works is you've got some data about what your store path is, where the actual binary is located, how it's stored, some hashes for the thing, what references they have, how someone can, what the driver is to reproduce it, some signatures. This is just the format. It's not the best format. There's some work to make this better, but it is what it is. One cool thing to note, though, is the URL doesn't actually have to be relative. So this could be somewhere else. So you could actually have your your nar info, your metadata, be put into a completely different place than you have all of your binary data. I think that's kind of cool. So I kind of came up with a crazy idea. What if we actually put some of these things in different places, right? You can kind of put them somewhere else. And if you want to go take a look, I decided, hey, what if I put them into GitHub releases, right? So GitHub lets you put something into your releases. And if you go take a look at this, I've uploaded basically exactly the same files you saw earlier, if it's familiar. And now you've created basically a HTTP Nix compatible binary store that just kind of works out of the hood. It's kind of fun, it's kind of quirky, it's interesting. It might actually be useful for some people, right? Because let's say you don't want to have an S3, you don't want to run some server, and here's some company that gave us some storage for free. I think it's up to 2 gigabytes or something like that, but like, hey, who knows? It might be fun. But there's flexibility in the substitutor system, and here's just one way to leverage that capability. If you want to play with that, I have that under Tom Barek GitHub store. If you want to play with it, there's a little app that kind of shows you that you have to like tag a release, then you upload the files. We have to do a little bit of sed replace to make the URLs work right with how like Nix usually does them, so you can kind of see what that is doing, but it's quirky, it's fun, it's interesting, who knows. All right, let's get this back. Okay, so as a recap, Nix has superpowers, right? We have these core concepts, we could do a bunch of like really nice things, and we want to be able to leverage them and expose these like superpowers, not just to like experts, but how do we make it that like those 100 engineers that were mentioned a second ago all have access to this without having to learn all of it, right? So that means we got to make the configuration easier. That means we got to make error messages better. It means we got to kind of document this better. It means we have to discuss it better and expose this to people, right? If it's just us using it, what's the point? I mean, I want to be able to make it so that as many people as possible benefit from this, so that when your coworker builds something, and then you build basically the same thing because you're testing their PR, why are you rebuilding it? Just use the same bits that they just used, right? There's entire organizations in like large companies that what they do is they go, hey, we're going to ship around today's development cache to all of my engineers. And they do this like every morning and they push it around. It's a 4 a.m. job. Like, I mean, this sort of thing is Nix just kind of solves. We should just leverage it and expose it, make it easier to use, nicer to use. It needs a lot more work. Hands down, I agree. This is something that just needs more attention in the Nix code base itself and our documentation in the ecosystem. So if you're interested in these things, like, get involved, right? That's kind of my call to action here. A lot of what I talked about today has nothing to do with the Nix language. I don't think I actually showed a Nix expression at all, maybe, I hope. This is all store layer things. Like, this is a store layer, this is reusable, has nothing to do with Nix the language. In fact, this store layer is usable by other systems, and that's kind of the intent. Famously, GUIX, Geeks used that like underlying store system, and we want to make this underlying store system more accessible to other people. All right, we discussed substitutors, remote builds, and we did a fun little kind of trick you could do with substitutors to kind of put it into an unexpected place, which I think was kind of fun. Questions? Oh. Sir. No. So now, if you try to build something and it's figured out that, oh, I need to build it, and it contacts that machine to build it, that machine will go, I've already got it, here you go. So you do kind of get some of that, but it's not technically speaking in the config a substitutor. It's just kind of behaves in a similar way, or the outcome's very similar. The question is, if you have a remote builder, is it automatically a substitutor? And the answer is, strictly speaking, no, but it does behave, you get the benefits as if it was. Sorry. Oh, one more question in the back, right. So that's okay, do I have experience with Attic? And how's that play to us? So there are smarter stores, basically, we'll call them, and store implementations that are out there. Attic is one, tvix has them. And basically, like, yeah, there's tons of additional features you can kind of provide, which I think is awesome. It's just that oftentimes the people implementing that kind of have to struggle with, how easy is it to create that thing over the long period of time? Can it be supported? What happens when upstream changes something and now we like break some part of the protocol? So that protocol's got to be better. It's got to be nicer. Again, documented, needs work. So my goal is to make those things easier to build, easier to maintain, and easier then to provide those features to, well, the broader world. That's the goal, right? That's it.
All right, thank you, Tom. Let's go ahead and get the next speaker up. Hello? Okay, there we go. All right, this is our last talk before lunch, and I just want to remind everybody, immediately after lunch, we're doing a Nix State of the Union, which is a keynote with Ron and Ilko and I don't know who else, but those are the ones that I remember offhand. So make sure that you're back here at, I think it's 1:30. Let me double check the schedule so I don't tell you the wrong thing. Yep, it is 1:30. So be back here in time for that, because that'll be sure to be interesting. But without further ado, let's let the next speaker take it away.
Thank you. Sound check. Can you hear me? Yep. Okay, cool. My name is Badi. I work at Intuitive Surgical, and we make robots. So these are not the sort of autonomous robots. These are more medical devices where there's a person operating some system. And so this is sort of showing an example of it. On the right-hand side over here are the instruments that actually go into the body cavity. This surgical team makes small incisions, and then the instruments go in. And everything you see here is set up so that the surgeon themselves could potentially be in another room doing this. The goal here is to have the best possible patient outcome with as minimally invasive procedure as possible. And the complexities come here in terms of as motivating factors for how we ended up with the stack that we're using are, that need to be built to make this to work properly. There's going to be an example of the scale a bit over here, but some of the interesting things here is that these tools give you a bit more degrees of freedom than our human wrists actually have. So in this case, this is something that's a bit closer. Is this better? Better? Higher? Yeah? Maybe? Okay. So that was, I'm not sure if that helped give you a sense of what the actual thing that we tend to build is. But there are some complexities that come from this. We're a regulated entity, so The development cycle sometimes is on the order of months to years. There are, in this particular case, there are many embedded targets that need to have their software built, tested, vetted, documentation provided, software bill of materials generated, and checked out. These systems are in use for a long time, long after the bits on the internet tend to go bad. In terms of development cycle, where we use a monorepo, which on single checkout is roughly 200 gigs. There's a lot of artifacts that go into there. We use work trees. Each of those can be, like last one I had was about 30 to 40 gigabytes, just as a work tree. A lot of the different components see a lot of churn, some of them less. And there are some external things that are these giant software blobs that have to be somehow passed along through the whole system. That provides a lot of issues. We have some very specific toolchain requirements. So we're at a point where the company has been in existence for like 25 plus years now. There have been several iterations of the product, several different build systems that have been used. The latest one is a combination of using Nix and Bazel. Both of these have some very specific properties that we're interested in. Big one that Bazel has is, that I'll talk about a bit more is granularity. But overall, we want to be able to build fast because then you can iterate fast, you can test fast, and have overall a better developer experience, and ultimately a better patient outcome. So some of the things that we need are to be able to reach really deep into the dependency graph of the software that we are building and shipping. We need to be able to cache different things because the big systems, in order to go fast, everything you have to have different layers of caching. We have to be able to do this without the existence of anything on the internet. So if Google went down or GitHub or whatever, we should still be able to build our software. So this talk specifically is less about here's something that you can do right now to build, to do. But this is more of a, let's take all these different ideas that we've seen at different talks at NixCon and show how we're actually composing them to have a stack that uses them. And as with all software, we have it working, everything's awesome, asterisk. There are a lot of issues. So this is a quick calibration for me. Kind of like, these are the general Nix concepts that we'll have in this talk. Does anyone not know what they are? Or is it helpful if I go into these as they come up in the talk? Yes? Yes? Okay. So, why Nix and Bazel? Nix, we have Nix packages, which has a vast wealth of knowledge of how do you build pretty much anything. And if it's not in Nix packages, a lot of the core ideas of how to build something in a reproducible manner are there. You can build things with auto tools. You can build things that depend on CMake. Some things are just bare shell scripts. You can build things that are just files. It doesn't necessarily have to be an actual build system. There is pretty good support for cross-compilation, which is kind of critical for what we're using. There's all this, like the last talk was about substitutors and caching, which are critical for how we're using this, though I don't really talk about it much here. Bazel has really a good cross-compilation support in different platforms. There's a good caching story. But critically for us, it has a very fine-grained build system where each of the different components are more or less content addressable. Nix has some support for that, but it's a bit more experimental and it's not quite as mature as we're looking for. So that's the ideas here is like take the best of Nix, take the best of Bazel, smash them together, and it works. So that's the sort of cake we're trying to go for. So Nix provides our interfaces with the layers of impurity. So anything that we need to pull in from the outside world, tool chains, libraries, that sort of thing, we shove them into Nix. And then Bazel has an interface onto that that allows us to build for a particular platform all the packages that it needs, and then expose them to the Bazel library or application for that particular target. So more concretely, these are the different things. So this is sort of the theme of the next bit of the talk, and I'm going to go into a bit more individually. But some audience participation. Does anyone know what this structure of thing is called? Or shout it out. A package? Recipe? Anyone else? Derivation? A function? So a lot of these are all right in a sense. We call this particular form of something, which is a function, to a derivation, a recipe. And the reason we call that is because that has been a good a notion for us to explain to our users who are developers at the company who don't really want to know, care, or should care about Nix, what it is that's going on here, and allows them to think about how we're composing the different layers together. So what's happening here is that this is a function that takes something called a standard env that produces a derivation. Its name is pname. So we're passing in the parameters to the make derivation function, like parameter of the name. The pname is hello, version, etc. We have some string interpolation where this hello.c is a path in the repository who then gets interpolated at sort of this build time to its location in the Nix store, and it builds this hello application, and then, excuse me, there's an install phase that then takes the output and shoves it into the target output. So, yeah, that's what we call recipe. This is something slightly different. What's going on here? Any ideas? Okay, I heard overlay. I heard overlay. I heard overlays, yeah. So yes, this is implemented as an overlay, but what we're trying to capture here is more or less a database of packages that are available to our systems that will later be used in different overlays. So in this particular case, we may have different versions of some library or application. OpenSSL, just to pick on that, is that you have multiple different versions of OpenSSL. You may want to experiment with a different version at a particular point in time for a particular version of your hardware that you're experimenting with. Say you want to go to market with one thing, but you don't know if this thing actually works, but you don't want to negatively affect everything else that you're building that's in sort of production. And so this gives you a way of exposing different things, but these are lazy. So this is not actually the overlay for, say, AR64 Linux or x86 or whatnot. So the way we're thinking about this particular component is a package database. And now, I heard overlay for this sort of thing, yes. This is what we're explicitly calling an overlay or a package set. Because for a given platform, and this could be bare metal, this could be embedded Linux, this could be x86, it could be a Ming W-based toolchain. You want to have a set of packages that are accessible for that. Overlays are a way of doing dependency injection into the set of packages that you have. And so this when you build the target binary, will inject those with the different dependencies. So in particular, in this case, we have some recipe for something that has different dependencies, systemd, for example. Some targets do not support systemd. Some targets do. Some things, like, I don't know why you'd want to turn off OpenSSL, but sure, this gives you the chance. And then the overlay is where you can compose these for that specific configuration. And this is how that comes in. So when you import Nix packages, there is a parameter to that import that you specify that overlay. And you can have multiple layers of these overlays that then get sequentially evaluated. And then in our case, we have cross-compilation support. So target A, target B, or whatever, gives us the ability to specify what we're building for. We are additionally using like overlays as an allow list. One of the issues that you come across with the mingling of Bazel and Nix is, at least with overlays, you expose your set of attributes in that overlay, but they're mixed in with everything else. And so when you're trying to build a particular version of, say, OpenSSL, you want the build to fail if you haven't exposed the right one, or if it's not explicitly set in the overlay. So we do some curse things, as someone was talking about yesterday, to make that work. So at this point, this is our stack. At the bottom, we have these recipes. Then we have a package database that then exposes all the different versions of a particular package. And then we have a particular overlay for the different targets that we're interested in. And now we need to expose them to Bazel. So this is where one of the, so when we expose something to Bazel, we need to tell Bazel, in this output, these are the different files that are accessible. Nix has a great feature of splitting the outputs into different locations, so into different paths. And so when you build a derivation, you build essentially the first one in your outputs list. But we often actually want the library files, or potentially documentation, that are not packaged in the default output. So we need to essentially symlink join them so that this takes all of the outputs, generates a new derivation, a new package that exposes them. And at this point, we are able to operate entirely in Bazel. There's some steps here that I'm not actually really going to cover. On the left, there's this register toolchains and toolchains.nix. That's where we tell Bazel that for a particular overlay for a target, this is how you actually invoke it, and how to expose those toolchains to Bazel. But there's some work there. The infrastructure that's driving some of this is a lot of the work done by Tweak, where you can expose Nix packages attributes to Bazel using the Nix packages, the rules Nix packages libraries. And at the very top, you have now your nice, beautiful Bazel library that depends on something in Nix, and it just works, quote unquote. So this is the type of commands that are like I ran yesterday, more or less. You have some package, you do a Bazel build, you specify the platform, and under the hood, that essentially calls down to Nix to build something like that generates the output paths. It then goes through the overlay to wrap those in the form for Bazel, and then Bazel has access to the files there that are then linked into this package that we're saying. And by changing the platform, we can potentially change the versions and so forth. So this is kind of a convoluted, complicated stack. You might ask how we ended up here. And we didn't start with this. We had a lot of the layers between Nix and Bazel where we just had the recipe, and then Bazel interacting directly with those. And that worked for a while, until we wanted to have a nicer interface that developers could have with the systems. Say, without this, the overlay, you would have to specify for a particular library in Bazel the version of the library that you're looking for. And that doesn't scale for the host of different targets that we're trying to build for. So yeah, it's nice and beautiful. Not really. So some things worked really well. If you've never used breakpoint hook in your Nix derivations for debugging, heartily recommend it. It's changed my life. What this allows you to do is you add a breakpoint hook into your native build dependencies or your build dependencies, and as the build's progressing, if it fails, it will pause, and you can directly enter the environment of the build and tinker around in a very mutable, impure way. Having the different access to the different layers, both for Nix and for Bazel, has made debugging much simpler. One of the issues that we have is many developers. We have a binary cache that we push all our CI artifacts to. So everything runs on a Nix build, pushes to cache. That's not public. So instead of having developers install directly from Nix, we wrap that up with like Debian RPM or whatever package. And that sets all the configurations. They just install that. We've been as we go through onboarding and talking to developers about helping them do the development that they need to do. Sometimes there's a need to add a third-party package or something, and they're not versed in Nix. And our job there is to make it easier for them to both think about what they're trying to do and how to do it. And so some of the terminology that we've been coming up with, like we found that when we talked about recipes, instead of derivations, things started to click for them very much faster. Let's see, yeah, caching is great. We recently had a issue where things were working previously without Bazel Nix by luck, essentially due to the impurity on the systems that people were developing on, and things started failing when in the Bazel and Nix world, essentially because we were catching a latent issue that no one had found yet. So all the rest is met with love. Let's put it that way. Talked about the multiple outputs. This was a problem until we until we were able to wrap this up. So fundamentally, wrap for Bazel is a sibling join. There's a lot of cross compilation here. We inject custom tool chains into the overlays. Sometimes we want to have a different tool chain build the entire set of packages, rebuilding the world. It's for people who are not very tuned into how Nix packages work or very familiar with the ecosystem, that can be a hard thing to wrap their head around. Talking to users about what does this mean, or why are we doing it this way? Having better ontology to describe the different roles for things and the different patterns that things fit into, and how they compose to provide the build that they're trying to ultimately do. I'm going to skip this one. We have an interesting situation where the target outputs are actually not running on a system that have access to /Nix, and we can't really copy the entire closure over. So we need to do some interesting things to make it work. So conceptually, Nix requires the interpreter to be present in the Nix store during the builds, but we can't actually point to the. But then that infects it, and so when you copy this over to the target, it can't be run, and so there needs to be some phases that split that out or change what that interpreter is, modifications to patch ELF, that sort of thing. There's some, say one in particular, is 20 gigabytes of something. that depends on a lot of other things, but it's depends in such a way that any modifications to what it depends on changes the this blob. And so every time that changes, new 20 gigabytes, new 20 gigabytes. It's easy to burn through terabytes in a development cycle. We don't have a solution for this yet. Yeah, if you know, you know. Yeah, let's see, how do I say this? Python is great. I heartily recommend Poetry to Nix for what we've experimented with. There are a lot of different options. Poetry to Nix has been one that has gotten a lot of things right, as far as I can tell. And I think, actually, yeah. Overlays and infinite recursion go hand in hand. So yeah, I'm actually just going to jump to the end. I want to leave room for questions. We're also hiring if you love Nix or reproducible builds. Talk to me, talk to my boss, emails. I'll be around here. Please talk to me. Questions? Yep. Yep. We take a look at the attributes that are in the overlay specifically and remove everything else. Everything that's not. And then, yeah, there's another layer that inspects it and does that. Oh, sorry. Yeah, the question was mentioned about how to use overlays as an allow list of the packages. And yeah, so I think I saw in the back. Yeah. Most of them only. Oh, sorry. What are the expectations for our developers between reading Nix files or having to deal with Bazel? Most of them just deal with Bazel. There are a subset, maybe 25%-ish, that do enter the Nix world. So I think they're in the orange sweater, yes? So question was, what does the CI environment look like? Patches to Bazel. So we try and push things to the cache as possible. There's a lot of remote caching, local caching, and disk cleanup on the fly, if that helps. I saw a question here. Yes, so, correct, yeah. The question, so, does Bazel call into Nix or Nix call into Bazel? It's Bazel calls Nix. Why we did that is this started out because we wanted the fine-grained builds that Bazel provides. Yeah, so like at like a few lines of code is more content just. Yeah, over there. With Nix. So everything is intended to be indexed by the repository. So you should be able to check out the repository and enter the environment, essentially a shell.nix. And that gives you everything. So you can upgrade Bazel, you can revert Bazel. The developers only need to run our installer for Nix itself, and it works. Yep. So the question is, how do we integrate with these blobs on the Bazel side? So because we want to be able to essentially check out the version of that binary by checking out a specific version of our code base. We have to provide it by Nix. And that's where the friction comes from, is really that iteration on the Nix side for people in unrelated teams can impact this because of just how it depends on, say, Python. And if you change something that Python depends on, which is a lot, or even one of the Python libraries, the way it's structured is that kind of blows up. But for how Bazel calls that, it's smart targets or rules that specifically say run the binary that this blob provides. It's less of an issue on the Bazel side here. But the challenge is that it needs to be provided the way we've structured things with Nix.
All righty. Let's wrap things up there. If you have more questions, meet the speaker outside or at lunch or wherever you feel like. But we're going to break for lunch now. And like I said, in about an hour, we're going to meet back here for our State of the Union with Ron and Ilko. So come back here for that.
1-1? Yeah, 1-1. Okay. All right.
You figure that out.
Yeah. Oh. No, it's okay. I think Ilko said he was going to be late, so I think that's fine. All right. Tom, can you be on slides? Can you be on slides? Click a click. All right. Can you guys hear me? I'm testing this new mic. 1, 2. Cool. We'll get started here. So again, say welcome, NixCon, second day. We're almost done with it, which is a mix of excitement and a bit of bummed, because this turned out to be pretty enormous than what we initially expected. And give you a bit of a backstory, we were thinking about this in September of 23, about 6 months ago, and then we said we'll do it. And then we did it, and then you all turned out. So really, everyone that was part of the organization team and making this happen, the foundation, the leads, just super excited to see this. And the biggest excitement is actually the number of hands that showed up of folks that were new to Nix from the last year. So those are the folks that we're excited to see here today, excited to come and integrate into the community, and hopefully you can give us that feedback, that fresh set of eyes, tell us how welcoming we are. Hopefully we're welcoming enough. And with that said, we do a Nix State of the Union. It's kind of like let's talk about what's happening within Nix, the different teams, and the overall overview. And the way we run it is that Ilko and I will talk about a bunch of stuff. Folks from the community will join in to talk about their areas. And this is just an attempt to also give a good overview of everything, as well as show some faces that are leading different areas inside the community. And really, the biggest ask is contributing, right? If you're excited about marketing or data or financials or design or obviously Nix packages contributions or architecture, it's like, that's why we want you to know. It's an open door, it's fully transparent, and we want you to talk. So with that said, we're going to start the Nix State of the Union. I'm Ron. You might have seen me before. I'm one of the board members of the NixOS Foundation and also the founder of Phlox. And we have Ilko here. Introduce yourself.
Ilko Dolstra. I started the Nix project a long time ago, and I'm a co-founder of Determinate Systems. And I'm also the president of the NixOS Foundation.
Next slide. All right, so we're going to have to do this because this is pretty big. I want to say giant thank you to everyone that took part in making this happen, the volunteers, the organizers. If you could just lift your hand, I'd love to just look at you again and say thank you. Are you out here, organizers, volunteers? I see y'all. Come on. All right, thank you guys. So, huge thanks to the SCaLE team. I have no clue how many folks are watching us live. We'll all have video recordings after this. You can come back to it or not. I'm sure it's probably a few million. And again, we had 2 Nix Pack days. So Ilko and I do this thing. It's just so you know, we're not AI. It's like, that's me. That's Ilko. So you don't get confused. Next slide. Cool.
All right, so first we'll have a bit of a look at some metrics about community growth. So this picture shows the size of NixOS releases, or rather the number of contributors and contributions. I'm a bit incompetent, so I wasn't able to update this slide for the latest release. But actually, 2311 had 2,100 contributors, so it's actually all the way up here. The Nix packages and NixOS community keeps getting bigger, and that's really awesome to see. Next slide. Also, for people who care, there's some people care about stuff like GitHub stars that grew from, I think I screwed up here.
It's, if you click one more button, it'll show it.
Ah, exactly. Yeah. So
We're really good in
9,700
design,
to 15,000 in the last 2 years. Number of merged pull requests in May 2022 versus last month went from 3,800 to 5,700. It's amazing number of contributions. And they're getting merged. I mean, we also have a lot of open pull requests, but yeah. So this is a picture that shows the number of repositories created every day on GitHub that contain either a default.nix or a flake.nix or a shell.nix. One interesting trend here is that you see a lot of uptake of flakes. So we have something like 50 repositories projects a day starting with a flake.nix in them. I think this is from the marketing team. This shows the Google Trends for Nix packages. I have no idea why it suddenly skyrocketed here, but that's great to see. Maybe Rock can explain that later. Okay, next one. And now the scary part, the binary cache. That's sort of the most critical thing that our infrastructure team provides. Everybody relies on the binary cache, and it's been around since I think 2012, and since then we've never deleted anything from the binary cache, so it keeps getting bigger and bigger. So, for instance, in September last year, it was 346 terabytes in frequent access, so that's the stuff older than a year. That has grown since then to 399. And we also have 140 terabyte in standard access, so that's sort of the recent stuff. And it went from, in that same period, so something like 7 months, from 770 million objects to 793 million objects. So that costs a lot of money. It used to be completely sponsored, but the company that was sponsoring that stopped doing that. So since then, we get some sponsoring of our S3 bill by Amazon, so we're very grateful for that. But it's not complete. Yeah, we can applaud that. But we still have a pretty big storage cost every month, something like 6,000 euros. So we're currently looking into garbage collecting part of the binary cache. Or maybe we can, if people think, hey, I really rely on the binary cache never deleting anything, then talk to us. Maybe we can figure something out. Also extremely useful to us is the Fastly CDN. We would be completely dead without them. So it's extremely efficient cache. So it has a cache rate of something like 98%. You can go to the next slide. So this shows the weekly traffic to cache.nixos.org has also been going up quite a bit. So we're getting something like 750 terabytes of traffic per week. And next slide. That is something like 1.5 billion requests per week. So we should really thank Fastly for their huge contribution. So applause, please. Okay.
Cool. So, yeah, going on from what Ilko was saying, I think the community has been growing, right? The usage has been growing, and we all love Nix. We all want to continue using Nix. As you can see, we're trying to make things as transparent as possible, right? How much data we have passed through. In a second, you're going to see some financials. the idea is that, as a community, as we're coming into this technology is not yet fully, self-sustaining. So help in that regard, both either by contributions or financially or whatever it is, hugely recommended and appreciated. And with that, I'll kind of tie into the NixOS Foundation. So it's a little teaser into it. I know there's a lot of folks that are new to the community. What is the foundation? We only meet once a week in Cloaks and in Ilko's basement. So other than that, we're a pretty cool group. But in reality, the foundation has two charters. One is keeping the lights on for today and tomorrow, but also helping to create a basis that makes the light shine brighter for the coming years and the coming weeks. And if you move one more slide, I'll give an example of the financials. Oops, slides got mixed, but one more. One more. Thank you. So examples of the foundation of kind of the actions that we take and the way that we operate is in a way where we currently have a mechanism that the foundation does not make technical decisions. The foundation is there to handle the legal, the bureaucratics, the financials, the pretty much the inbound of funding, the fiscal hosting, and everything around that clause. But also the foundation is trying to build up a muscle and a mechanism to help unblock and facilitate community level escalations. So the foundation is, again, not a group of folks that hide in some basement. We really encourage you to reach out to us. There are more than probably 10 ways to reach someone from the foundation. One is obviously in person at NixCon, but two is on Matrix, on Discourse, on email, on everything. And we really appreciate that. The other thing I would say is that foundational conversations, there are no barriers. There's nothing that the foundation is talking about that you can't take part of if you care about it. So a lot of times there's assumptions that there's things that are not really talked about, like, internal financials or partnerships or decisions that are being made behind closed doors. None of that is the case with the way we like to perceive things. So if you care about it, reach out, we'll involve you, you'll be part of that. So, and also give us that feedback. So just some examples from 2023 and leading into this year was, we'll talk a little bit more about the S3 grant. So we did have a situation where a long-time contributor financially had to drop out. The community did an amazing effort and we were able to secure funding, again, from AWS and partners and contributors and a long-term effort around that. There's a lot of building up relationships that we're doing, right? There's a maintenance cost to it. Like, we need to keep talking with Fastly so they don't wake up one morning. It's like, what is this bill going out for $50K a month? And we're like, oh, no, it's the cool guys at Nix. Grant and event funding program. So we launched that actually for the first time last year, where Nix has a grant program. If you want to do something smaller, because we're not yet a multi-billion-dollar community, but if you want to do something smaller, like a meetup or a get-together or some like Nix hack, or buy a sign for a conference that you want to go talk about Nix, we have a way that you just fill in a form. We try to approve them almost on a weekly basis, and we're pretty happy to do so. Those who are not familiar, a lot of the funding that is coming into Nix comes from a European project called NGI. And I don't know if Ilko will have a chance to touch on that a bit in a bit, but that is a huge program that allows to fund a lot of Nix-related efforts. So we're in the US, North America, lots of North American here in the crowd. If there's projects or programs or grants that are also tied to the governments on this side that can be tied into the community and help support the community, we'd love to do that, right? We don't have visibility into everything, and the more we know, the better. So that's really big. Another thing last year was we started a formal effort with funding for the documentation team, right? Making Nix easier to adopt, bringing in folks that know how to write docs. I have no clue how to do that. There are folks like Zach Mitchell that know how to do that, and he's helping lead that effort. And then a bunch more. The one click. Now, what do we care about moving into 2024? So we care about quite a few things, but there's a few big ones. One is we care about how do we grow as a community. And growing as a community means that we need to be able to bring in more contribution, open things up more to newcomers, but it also means that we need to be able to fund efforts. There's only so much scale that we can achieve by hoping that everyone here has 2 hours over a weekend to go and contribute to it. Now, there's going to be some of us that are crazy and want to go into the nights with, I see some folks laughing, it's like, you guys, and do this as an unpaid full-time job, and thank you. But there's going to be a lot of efforts that we need that funding for. And therefore, a big focus for this year is how do we define funding inside of the Nix community? Up until now, it's been donations, and you'll see that in the financials that I'll jump to in a second. We've had a major range of about $40,000 to $60,000 of euros of donations a year. That is not enough to make Nix sustainable, which I'll also talk about. So there is a big topic because some of that funding will need to come potentially with a transactional relationship. A donation is kind of like throwing cash or leaving it at our door and saying thank you. But if we want to go bigger and we want to be able to bring in folks like, for instance, Fastly, or put them on the site as a logo or things like that, what do we feel comfortable with? It's discussions that we should have the community, know what we're comfortable with and move forward on those regards. So that's one. The second one that Tiofan will be talking about is empowering teams and individuals. Right, so we've been small, we've been hacky, that's been able to let us progress. How do we move from that phase to a phase where folks coming in or just folks existing in the community for a while feel empowered to make decisions, right? Like, I don't want folks to feel like, oh, I'm gonna make that decision, what if there's pushback? And that is creating kind of like lowering the bar or not allowing people to come in and make an impact. So that's happening. That also has to do with funding, that has to do with teams and individuals and all of that. And one of the discussions that, I don't know if folks have been online recently, but it also is tied to funding. And one of those discussions are around sponsorship, right? How does the community feel about sponsorship, and how can we create a policy that, guess what, is reproducible, because that's what Nix is. As we grow and as we become more professional and more official, and as we want to grow into a wider in-house name, and every developer, and maybe even being taught in college or whatever it is, we need to be able, for the external perspective coming and looking at us, to say, I probably know how this decision will look like in 6 months because there's a policy in place, there's a sentiment, there's an expectation, right? When we're small, when we're hacky, we don't need that. We're like 50 people, 200 people in a room, and we kind of get each other. When we're starting to expand to communities of 100,000, 500,000, we want folks to feel welcomed and safe, whether it's whoever that person on the other end is. And a lot of that has to do with defining things publicly, making them transparent, so that they know how those decisions are made and what they can do within our community. That's a little bit about the foundation. I'll pause in a minute for questions, and we'll do questions at the end. But before that, Tom, can you go back to the financials? Cool. So we're going to be releasing another deeper snapshot of this. We try to do this at least once a year. It gives you a look at anything that's coming into the foundation and going out of the foundation. These are the things that are on our books, right, from AWS to miscellaneous. So this is like Ilko's protein bars. No, I'm kidding. The costs, but the serious costs that are not on the balance sheet that Ilko mentioned are things like Fastly, like Equinix Metal, and those are really, really big costs, right? So that means that if tomorrow morning, for some reason, one of these sponsors, donors decides, I don't like what's happening in Nix, or I don't want to do Nix anymore, and they drop us, concerning. We had that situation kind of come up with the S3. We were able to come together as a community and solve that, but we don't, we want to create a baseline. We want to create a treasury that is able to become self-sustainable. One click. Thank you. That's the goal, right? The goal of the foundation today is to make Nix self-sustainable, meaning that we have an income that is allowing us to operate with a 12-month buffer, meaning that all of you can go to sleep totally well at night, knowing that your systems are running Nix, NixOS, Nix packages, and all of that, and you'll wake up tomorrow, and no matter what, everything is going to be fine for at least 12 months, even if everything suddenly drops all of a sudden. Do I want 24? Yes, but 12 months is usually enough. I think we're a strong enough community, we can probably figure it out in that timeline. So that's what I wanted to talk about there. Let's skip forward. One more. So the quick S3 story for folks that weren't here, sponsor couldn't fund anymore. They've been funding it for 13 years, which is insane. Sorry, this is a really great drawing. I'm really good at this. So we actually, sponsor decided to drop off. We were notified. We kicked off a S3 community thing, kind of like, hey guys, making it transparent. We're looking for solution. It took us 14 days. In those 14 days, there were hundreds of community members that came together to think about short-term resolutions and long-term resolutions. There were dozens of community members that offered their services for companies that they work for and things like that. And that's what it means to be an insanely strong community. 14 days it took us to the time where AWS came in, gave us the funding and the sponsorship for 12 months, and allowed us to do what was important to start thinking about the long term of it. How do we make the S3 more sustainable, right? And Ilke, you want to say a few words about long-term S3?
So yeah, the long-term plan right now is that we'll do a periodic garbage collect of cache.nixos.org. So that kind of hurts because we don't want to harm the reproducibility of Nix packages in NixOS. In theory, of course, you can always rebuild ancient versions of Nix packages from source, except of course that those sources might have disappeared. So that's why a lot of people still rely on things like source tarballs being in cache.nixos.org. So we want to go about this in an intelligent way. We don't want to just nuke every store path older than 2 years, for instance. So the current plan is that we're first going to delete old NixOS and Nix packages releases, meaning probably something like NixOS and Nix packages releases older than 2 years, except for the most recent version of every release branch. So we would keep, say, the most recent version of the 1709 NixOS release. So you can at least still use that. So the releases that we keep, those are the garbage collection routes. So every store path reachable from the packages in those releases, we will keep them. But we will also keep all the fixed output derivations. So we will not get rid of things like tarballs. So you should still be able to get a version of Nix packages from 2013 and rebuild it from source, because the sources will still be there. It will just take a lot longer. Yeah, so we'll delete the releases, or rather we'll initially move them to Glacier. So if it turns out that this was a really bad idea, or somebody says, hey, I'm willing to contribute $10,000 a month to make sure that you don't have to garbage collect, then we can still recover that stuff. And then a little bit later we will start doing the same for the actual store paths in the binary cache. So that's the plan right now, and we would probably run this garbage collection every 6 months or every year or so. We still have to figure out those details, but yeah, that's the plan. And so so to reiterate, right now we're paying $6,000 a month for the binary cache. That's on top of the $9,000 a month donation from Amazon, and we have to fairly substantially reduce our storage costs, so something like 50%. And make it long-term sustainable, because the cache cannot keep growing forever, probably. So yeah, that's the current plan.
Cool. So again, because of the show of hand, I totally did not make this about 2 hours ago, but if you're new to Nix, first of all, I really do hope that you had a chance to build relationships, see faces today that you're going to be able to connect with, and just build out the next few steps for you. But in general, and I know this has been said, the community operates across Discourse and Matrix. So one of those, join in. You can find any of us, like most of the folks in the community on there. Message, don't think twice about it. If someone can help out, they'll try to help out. If they can't, they'll find someone else that can help out. So really, be open to it. There's teams and leads. You can find that on the NixOS.org website. If you're not finding the solution on Matrix, you're not finding it on Discourse, feel free also to reach out to teams and leads. There's obviously all of us at the foundation. There's also Nix.dev for documentation and for onboarding and everything like that. Next. Cool. So I'll take a quick moment there. I've decided we'll do questions at the end, let everyone kind of flow through so we don't run out of time. And with that, I'm going to hand the mic over to Ryan. So thank you guys.
Hello there, thank you. So I'm going to present some few things of the community. I'm a NixOS developer in the community and also board observer for the foundation. We have the moderation team, which has seen some growth. We had some departure, we had 2 new arrivals. For example, we have 2 new members, Pi Games and Ryan Hendrickson. And yeah, it's the moderation team is one probably of the hardest jobs you can have in the community. It is very hard to balance out the opinion of each other and ensure that people can be productive in that environment and still feel safe and still feel heard with their opinion. So I really think that it is a team that we should support, a team that we should be very thankful for, and a team that is very hidden and silent in how they operate. So thanks to them, and they also NixOS contributors on the side. You can recognize some of the nicknames, I'm sure, for example, Python updates or MiG92, various contribution to the whole ecosystem. I think we can go to the next slide. So another big infrastructure, another big team is the infrastructure team. So we have the infrastructure team is composed of two sub-teams. The first team is the build infrastructure team. The build infrastructure team handles the machine that will build all the derivation, all the packages of Nix packages. Obviously, it's very, I would say, a bit sensitive because you have a signing key, you have private key material, you don't want to your packages, your cache packages to be poisoned. So it is a critical mission for the build infrastructure team to handle them. And not all the members listed here are build infrastructure members. So for example, Jonas is build infrastructure, Vladimir is infrastructure, Martin is infrastructure, build infrastructure, sorry. Thanks to them, they've been working on cleanup of the infrastructure repository, so looking at all our infrastructure machines, saying, oh, we are paying too much for this machine, we should probably consolidate it into this other machine. And so they achieved things like $700 per month of savings, which is a really nice start in a very fast amount of time. It is very exciting to see them at work, and thanks to them. And then we have another team, which is the non-critical infrastructure team. So in the community, we have many needs. So for example, sometimes the release managers need a calendar so that they can inform the community of when is the new release, and you can subscribe to that calendar. For example, also the marketing team might need some infrastructure to send newsletter or surveys. And those are what we put under the name of non-critical infrastructure. It is a much more approachable team that you can join as a system administrator, where you can work with people to use NixOS for NixOS itself. So you can see new members. We have plenty of new members in that new non-critical infrastructure, and plenty of projects available in the GitHub repository you can find here. And yeah, we have long-standing issues with our CI stuff. So Hydra, for example, we had a workshop on CI. The scale of Nix packages is so big that we have unique challenges appearing, and I would say technical debt to clean up. So we have a lot to do on performance improvements, and that's probably what we're going to focus on for the next years. I think we can move to the next slide. I will pass the micro to Garbas.
Hey, lots of you are using Nix for quite a long time. And quite a few are new. What you're going to face is you're going to talk about Nix. That's what I did, and they told me this is marketing, so marketing team. Yeah, so if you want to, we try to spread the word of Nix around the world. What we do, we cover all the social postings that we try to do a frequent job. The newsletter, which was revived but will be put on the website very shortly. The website itself, we finally reached the point where we can work with the website a bit faster. So, and we need a lot of help with the website. So if you know some of the CSS, you don't have to do a lot. Please help us. This is where we need. And then we are also collecting certain metrics. One metrics which I was promised to explain was this one. Why this jump? You don't see it. I barely see it myself. Started at 2012, the graph. This is where the growth started, is in 2020. And then the big jump actually happened in April, May last year. I have my theories. They are not to be publicly shared because apparently I have strong opinions. No. it's just Nix got picked up by a lot of social media, YouTube content creators, and that's the spike. Most of you also heard about this now. What do we do with this? I think we are just on a good path. We need to provide good documentation. That's why all the work that's been there is very much appreciated. And I mean, come on, this graph looks just good, right? It's like we're going up. So, thank you.
So I'm going to do this pretty quickly because we're kind of starting to run out of time, and I think we're already over time. So this is actually a slide from Sylvan, who wasn't able to be here. Sylvan actually sunsetted the architecture team a bit ago for a multitude of reasons, where you can click on the link and then see it on the deck. But Infinicil is continuing to do this and continuing to work on architecture. And the general ask is that you know that it exists, you know that there's a need. If there's folks interested in this area, please reach out. Please, come on in and help make it happen and volunteer. And I'm sorry that I'm running through it, but there's multiple channels that you can do it. Sylvan and Infinicil also does weekly office hours, which I can only highly recommend. To you, fun? Mike.
Oh, okay. Okay, thanks. So I guess I have to be quick too. So very briefly, we saw a bunch of teams and teams effort and all that. One issue we had, if you remember the graph of like this great, huge exponential growth, is that, well, if we have this growth, it's great, but then it means that we need to have some kind of structure around that, because otherwise new joiners just arrived and see these huge things and what the hell do I do if I want to help? So that's one axis that we wanted to put some effort on, and we've started on that. We're still going on to really try and give some more structure so that people can know how they can contribute, so that they just don't know how, but they have the ability to do that when they want. And they can also know what's going on, regardless of whether they want to contribute or not, which is this whole team empowerment effort to try and give some structure to the main groups that are acting around the different parts of the ecosystem, being like different like technical parts, Nix packages, NixOS, and the non-technical parts like the moderation or the marketing that we just saw earlier. And that also ties to the fundraising aspect, because if like companies maybe, or any companies, institutions anywhere might be glad to give money to the Nix ecosystem to do things, but then we need to be able to spend that money efficiently, and that means that we must have some kind of structure to know how we can give grants to people or groups of people to do things efficiently, and that all ties to that subject. That's me again. Okay, so that's probably the 7th exponential graph that you see. It's always a bit the same thing. That one is the number of Nix contributors per year from 2015 to now. You see it's a nice, great exponential curve. We're all happy. Nix is getting more popular. But now we have scaling issues. The original Nix maintenance model was Elko doing a great job at developing that as a PhD student. Obviously, that doesn't scale when you have more than 200 contributors. So we need to change the way we develop things. Can you, yeah. And that's why, so a few years back, we created the Nix maintenance team, whose goal was to improve the experience for contributors, to make sure that they would want to keep contributing, bring back good contributions, and eventually help maintaining the thing, because that's always the trade-off. You have contributors who submit new features, but then they need to be maintained, and you need to review them, and all that. And you need to have a good ramp path so that people can eventually help maintaining the thing. And then the other problem is that, Ryan mentioned technical debt for Nix packages. Nix is pretty good in that aspect too. And there has been a tendency to just add new features to Nix, not always completely finish them because it's cool, we have something that works. So I have something that works for me, it's in Nix, I'm glad. Maybe it's not completely documented, there's a few edge cases that people are not happy with, but then I lose the motivation to finish working on that. And that's our second big goal, to really finish up all these kind of things, sometimes small things, sometimes big things. I won't say the flake word because that can be a dangerous thing to say, but we really want to try and finish all this work in progress that we have. And that's also something where we can get a lot of help. There's a lot of small-ish tasks that can be accomplished as a, like, even if you don't yet know the code base, even if you don't know C++, I'll be honest, I've been working, like the first time I've worked on Nix, that was one of the biggest refactorings of Nix that happened. I had never written a single line of C++ before. And it took me a while, but eventually we got there. So please do come and help.
All right, gonna keep doing this pretty quickly. So once a year, we started this in 2022. Shit, we're in 24. We started this in 2022. We started doing a survey for the entire Nix community and those that are interested in it. This is the biggest survey that we've ever ran. So the last survey was 23. 2,500 responses, 47 questions, and it's online, it's on the discourse, go and read it. 92% are Nix users, 8% are not so surprising. There's some data here, I'm gonna skip by it. Lots of interesting stuff, lots of very surprising things. Bottom line, what we're asking for, give me a second. Pretty much what we're asking for is very soon the start of the next Nix survey is going to kick off. One, if you have survey experience or are just curious, join us. There's a channel on Matrix. If you're curious about things about Nix and want that question to come up into the survey, then advocate for it and we can figure it out. Number two, when the survey comes out, it is insanely paramount that you help us get it to as many people as possible so that can feed back into the community so that we have data to base things on. Guillaume kind of leads this. He's awesome. He also wrote this about a few hours ago, and thank you to him. I don't know if we had anything to say about release management really quickly. It's coming up.
Oh yeah. So about release management, so we have 2405. The release is in by the end of May. During the release management, we will call for release manager, a release editor. Release manager is mostly technical. Release editor is mostly editing stuff, editing the release notes, making them cute, making them cool, so that people who will read them will be excited about the new release. And you can help. You can join and you can like help the release community to release NixOS. And the last important ceremony of the release is the Zero Hydra failure. So this is a ceremony where we call everyone during the beta phase of NixOS 2405, and we will be in the PRs, waiting for new PRs to fix new packages, fix new NixOS tests, and everyone will try to merge them and get the number of failures super down. And this is how we ensure that the stable release of NixOS are indeed stable.
Cool. So you already found out about this. Usually we do this on the first slide on the first day of NixCon, but there is the Nix Pog. We still have a bunch left, so as you're going throughout the day, stop by some of the booths, collect them, and then maybe at some point you'll be able to buy something with them. This is actually a picture from the first NixCon post-COVID that Ryan helped organize as well. It was even more hacky than this, if you can believe it. Crazy. Bottom line, I think, again, we wanted to thank everyone for coming out here. I'm sorry we didn't have time for questions, but there's a bunch of other great speakers that we're pretty eager to hear and not just take up all the time on stage, but we're going to be walking around. We're going to be outside in the kind of like unconference zone, so find us and hassle us about things that you care about. And really, again, just lots of love for joining this community or being part of this community, and if there's anything we can do, let us know. So thank you guys, thank you everyone for speaking, and have a great rest of the day. Thank you.
All right, you guys go ahead and get set up, and then I'll make an announcement. Yeah, you will. Just let me make an announcement. Okay, yeah. All right, folks. We are going to start the next talk at 2:15, and then the rest of the schedule will just be shifted back by 15 minutes. So UnConference will start at 3:15 rather than 3, and whatever else is on the schedule, just add 15 minutes. You'll figure it out.
Okay. Are we good to start? Yeah. Hello, hello. Okay. Hello, everyone. Welcome. Thank you for coming. A quick disclaimer before we start. This talk is mostly aimed at beginners, so if you're a NixOS expert, you might already know a good amount of the stuff here. But we still hope that you'll take away something new and be motivated to set up your own home server by the end of it. So with that being said, let's get started. So imagine you just bought your brand new mini PC and you want to set up a personal home server. Well, first let's install some software to it while it's still pristine and brand new. So let's say we want to set up a media server to share your personal media collection with your friends and family. Well, we can do that. Let's say we want to set it up with Docker. We'll have to write a Docker compose file, get that set up, put that Docker compose somewhere in our system, figure out what port this service is even using, open that in our firewall, and much, much more. Okay, that's fine. Let's say we want to set up a photo backup server. Okay, that's fine. Let's write another Docker compose, put this somewhere else on our system, and then also open this port in our firewall. Okay, sure. Well, the more services you add, you end up repeating this dance over and over again. And by the end of it, it kind of gets out of hand. And if you're just a sole server maintainer, this can get very overwhelming very quickly. And we think this is madness. Today, we're going to be proposing a solution to this madness. My name is Anthony Tarbunian.
And my name is Samir Rashid. And we're presenting Nix Magic, the case for Nix on the home server. So we're both UC San Diego students, and let's get into it. What are the benefits of a Nix home server? Today we'll be discussing how Nix allows you to fearlessly modify your home server, easily keep track of system state, and make sure that your home server, managing your home server doesn't feel like your 9-to-5 job. So let's quickly go over some background. What is a home server? A home server enables you to host your own services on hardware that you own. You can host your own photo backup instead of relying on services like iCloud and Google Photos. And in addition, you can host other things like a media library, you can host your own website, and store your own backups. You can find self-hosted services for pretty much anything you can imagine. So is this going to be expensive? Well, no. A lot of people think you need a beefy PC or you need some rack-mounted case, but you really don't need anything. You can use just a NUC or a Raspberry Pi, which is pictured on the left, or just an Intel mini PC. There's many good reasons to make a home server. I think some of the good reasons are you can take back your freedom. You don't need to trust big tech with your data, worry about Google axing some service you use, or be at the mercy of VCs who are going to put ads in your paid product. Also, it's a lot of fun to play with software and have an environment where you can do anything. So what's Nix? The term Nix includes the language, the package manager, and the Linux distribution. The naming system is kind of complicated, but basically this is just an ecosystem built around the Nix package manager. We'll be talking about the Nix operating system, NixOS, which is a Linux distribution which includes the Nix package manager and allows you to configure things about your OS. But you don't need NixOS to take advantage of Nix. You can install just the Nix package manager to other OSs like Ubuntu or macOS. You use the Nix language to write a configuration. So when you write this configuration, it'll be written in the Nix language, and then you can build this file to declare everything that's on your system. Building your configuration means that Nix will install all the packages you specify, generate any config files, and start any services which you want. Unlike other package managers, Nix will do the same thing every single time. You should end up with the exact same system no matter where you build it, when you build it, or who builds it. This means you can write your configuration once and build your system anywhere. So Anthony, can you show us what writing a Nix config would look like in the wild?
Yes, so let's look at some real Nix configuration. So let's start off with explaining that Nix configs are just text files. The Nix language itself is a happy medium between a configuration format and a programming language. This is advantageous because it gives you access to things like functions, data structures, and variables. So let's look at this sample snippet of Nix configuration. So You can set up your system so that all your configuration is located in this configuration.nix file. And here we have a few lines. The important thing to note is that we're modifying this system packages variable. And this variable will store all the packages that you want Nix to install to your system. So by just looking at this, I can tell that my system will have vim and git installed. Okay, that's fine. Let's say I want to add a new package. Well, it's as simple as adding a single line to this configuration. If I add this line and I rebuild my system, I'll have access to something like tmux. Okay, this is cool. What else can I do? Well, you can configure settings of common services in your Nix config. Here we're setting an option for the SSH daemon. For context, this is just another part of that same configuration file we saw earlier. This means that you have full transparency into what's going on in your system. You can see all your services, how they're configured, and other stuff too. Here I can see that I'm enabling the SSH service and setting an option to block login attempts for the root user. This is nice to have this all in here because I don't need to go digging for the SSH config, which is somewhere on my system. It's all right here in my centralized Nix config. Okay, Samir, can you tell us how to get started on installing some services for our home server?
All right, let's look concretely at what it's like to set up a home server with and without Nix. First, let's try setting up Jellyfin, which is a popular open source media management software. So if you want to install Jellyfin on a traditional Linux system, the Jellyfin docs will suggest, oh, you should just curl our install script and pipe it into sudo bash. But, I mean, this is very suspicious. This script could be doing anything. We checked and it's just adding their apt repository and installing their package, but in general, the problem with running bash scripts is it can be difficult to revert their effects. You would have to, and you don't really know what it's doing. You'd have to figure out what packages it installed, what files it modified, and try to undo all of that manually. On Nix, if you want to do the same thing to install Jellyfin, it's just one line. You can write services.jellyfin.enable equals true in your config. And uninstalling this and removing everything Jellyfin put on your system is as easy as removing this line. But what is this line actually doing? When you build your system with this line in your config, Nix is going to take care of downloading and installing Jellyfin. And it'll build it if Jellyfin needs to be built. This is going to use a Jellyfin, or this is going to use a recipe that's inside of the Nix packages, which is Nix's package store. So as soon as we add this line and rebuild our system, we should have Jellyfin available in a matter of seconds. Let's say we want to add another service, like Samba, for sharing files over the network. Normally, when you're setting up a service that needs to be accessible by other computers over the network, you're going to have to open a firewall port. So on a normal, without Nix, in order to do this, we're going to have to first look up, okay, which ports is Samba going to use? And then, oh, what command am I going to have to run to do this? With Nix, all the state is in one place. Nix is going to handle the complexity of opening the port with this open firewall option. You just set that to true, and then Nix will open the port and do whatever it has to do. And then let's say one day later, we want to uninstall Samba. If we uninstall Samba without Nix, then this firewall port is going to stay open, and it'll have just left state across our system. But setting enable to false in Samba in our Nix config is going to undo any state change that has happened. Okay, now we have a few services running. Let's try and access these with some nice local domains rather than memorizing their IP address and port numbers. So we can use any reverse proxy. We'll just be using Nginx so that we can route everything through normal HTTP port numbers. So the first thing we're going to have to do, let's say we've installed Nginx without Nix on a non-Nix system. The first thing you're going to have to find is the Nginx's configuration file. So, okay, we'll look this up. We'll search this up on the internet. But maybe in a few weeks, I want to edit this file again. I'm going to forget where this file is located and have to look it up. So the first problem we're going to face is that there's too many config locations. Every file or every program is going to have their own configuration file. And this issue can bubble out of control, as you saw in the intro. All these programs are going to be littering your computer with configurations and dot files. Okay, let's say now that we've found this config file location, we want to add any setting. Well, Nginx uses a bespoke configuration language, which they invented for themselves and only they use. So we've faced another issue. when you're setting up a normal home server, you're going to be faced with tons of different configuration formats. Everything uses its own language or configuration format, and it's going to have its own set of options and quirks which you need to memorize. So Nix is going to solve this for us. To do the same, just to set up Nginx, we can just put this snippet in our configuration. You can see this is going to route all incoming traffic to jellyfin.local to whatever Jellyfin's internal port number is. We don't need to worry about where the config files are going to get generated, where they're going to get put, or have to learn Nginx's configuration language. So you might be wondering where we're getting these options from. We didn't have to write any of this. This is all offered by Nix, and you can find all of Nginx's options in the Nix option search. So you can see here, if we search for services.nginx, there's 160 results which list everything we can configure with Nginx. So in summary, Nix gives you less cognitive overload. You can define all your open firewall ports in one place, all your systemd services. There's only one config format for everything, and it's all in one place. So Anthony, what else can Nix do for us?
Okay, let's look at another really powerful benefit we get from using Nix on our home server, which is reusability. So by default, Nix configs are modular. This makes it really easy to take a part of someone else's config and just copy paste it into our config, and things should just work. It's as simple as copying a snippet of a Docker compose into yours and just running it. So setting up new software can be challenging. You have to go use an installer, you might have to modify some settings on your system, might have to mess with some networking settings, et cetera, et cetera. Also, if instructions online are out of date, you can spend hours and hours debugging why things are going wrong. Let's look at a notoriously hard problem with self-hosting, which is setting up your own mail server, which some consider to be the final boss of self-hosting. Mail servers are complex. You need a daemon to send mail, another to host your mail client. You might want some virus scanning software or a spam filter. Well, thankfully with Nix and the Nix community, there's already this amazing NixOS mail server project, which we can just use in our config. The entire setup is just this sample Nix config you see on the right. There's no manual steps to run, and if we just move this into our config, we'll end up with the exact same mail server as the person who made this. So it's not 20 pages of commands that you need to run. It's just a dozen lines of configuration that you can add to your own personal configuration. And if you can read it at the bottom, the only command you'll need to run is NixOS rebuild switch. This is so much easier than having to follow a project's potentially out-of-date instructions. The great thing here is there are no instructions to be out of date because there are no instructions. Once you experience the power of declarative configuration, you'll never want to go back. Let's look at another example for our home server, setting up a VPN. In this example, we're going to use WireGuard. And the use case here is, let's say we want to access our home server services from anywhere in the world, but we don't want to expose each service to the public internet. Well, we can just connect to the VPN and access everything that way. So similar to the previous example, there's a WireGuard example online. It's linked at the bottom if you go to that NixOS wiki page. So someone else has posted this, and you can really easily just take it and put it in your config. Just have to modify a few fields with the private keys and whatnot, or public keys. And yeah, and again, uninstalling is trivial. You just have to remove this config, or these few lines of config from your configuration, and WireGuard will just disappear. And the great thing is for something like this is Nix will take care of undoing any complicated networking setup that we might have had to do to get WireGuard set up and working. So on the topic of reusability, Nix makes it really easy to reuse your config across multiple machines. So imagine you want to SSH into your home server. Well, you don't want to feel like you're SSHing back into the 70s and be greeted by antiquated a diff utility looking like this on the right. Maybe you want something like what's on the left, which is called Delta, a modern diff utility. So with Nix, you can just copy your modern terminal utilities to use them wherever you go and even on your home server. Which is really nice. So let's look at another huge advantage of using Nix on your home server, which is how it makes it painless and trivial to upgrade your server. So let's talk about why you might want to upgrade. It might seem obvious, but you might want new features of your services. Let's say Jellyfin releases a new version, you want a new feature. And security is also a huge concern. Every day there's new security bugs being found, and those same bugs are being patched all the time. So you want to make sure you're always up to date so you don't end up being the victim of the next log4j. So on a system like Debian or Ubuntu, which your home server might be in, you might run a command like sudo apt-get upgrade and move on with your day. And you might be thinking, okay, this is fine, but like, what could go wrong? Well, it turns out a lot. There are many things that could go awry. Maybe the latest version of Jellyfin has a dependency conflict, or maybe there's a bug in a new release and you want to move back to a previous state. Does this really happen? Are there really like issues with dependency conflicts? Yes, trust me, I know. Also, you can see like many users online have faced the same issue, especially the one at the top, which has been viewed 1.5 million times over the course of 11 years since it's been posted. Also, there's a notorious example of Linus Tech Tips breaking his system when he tried to install, I think it was Steam, on Pop OS, so with apt. So yeah. So with Nix, or with something like apt, it's impossible to roll back. Whereas with Nix, it's very easy with this NixOS rebuild rollback command. So yeah, you can always move back to a previous working state. Some would argue that you could do the same thing with apt. There's some commands like apt update, -- fix missing, but those don't really provide a complete solution. They're more of a band-aid to try to give a best effort to try to fix things. Whereas with Nix, you know for sure that if you had a working state before, you'll be able to move back to that working state. This is also really advantageous for a home server scenario because you want your home server to be up all the time, and if something goes wrong during an upgrade, you can really easily just move back to keep your services up and running. So let's talk about like how rollbacks actually work or what they are. So every time you build your system with that NixOS rebuild command, it'll create a new version, or we call it generation. So here you can see on this boot screen, we can see the past generations that I've built with Nix. And then when I boot, I can switch to whichever one I want. It's like having Git for your whole system. You can move back to working versions seamlessly. Technically, some might argue you could achieve the same thing with things like file system snapshots, if you've heard of file systems like Btrfs. The problem with those solutions is they manage every file on your computer, not just system state like configuration files and application binaries, whereas Nix won't touch any of your user data, which is really handy. So how does this thing work under the hood? Well, it's just symlinks all the way down. When you upgrade, Nix won't overwrite existing packages. So let's look at this example here. So let's say my current system is on the thing on the top, system 1 link, and I currently have a version of Jellyfin, let's say the stable version. Okay, sure, let's say I want to upgrade to the unstable one, but oh wait, there's a bug, or I don't know, I don't like how the UI looks now, I don't know. Well, with Nix, I can really easily just revert back to the old version, and it's just a matter of like changing the symlink to the previous version of Jellyfin. So this is a really powerful model, and it also helps in the case of version pinning. So let's say you want the latest version of some package, but you don't want your entire system to have to move to unstable. Well, with Nix, you can do this. You don't have to go get onto a bleeding edge distro like Arch, where it's either all or nothing. You don't have to bleed to access the bleeding edge. Also, in the case of having the most stable packages, you don't have to move to something like Debian, where it's also all or nothing, and everything is just super ancient and stable. With Nix, you get the best of both worlds. And this is impossible to do with other package managers. If you look on the right, you'll see this graph here. So we have a package that depends on 2 dependencies, or 2 libraries, which have their own dependencies. And normally it's impossible to have or the same dependency and have multiple versions of that 2 packages rely on. With Nix, you can do this and have as many different combinations of dependencies and packages that you want. You can also see the little snippet at the bottom. That's a little indicator of the kinds of things you can do. So here we only want to have Jellyfin use the unstable version. And this is great because it doesn't mess up anything else on our system. The rest of our system is still unstable, and we can experiment freely and not have to worry. So so we've been talking about how great Nix is. Let's compare it to a popular tool for managing home servers, which is Docker. So Docker is great in the sense that most home server applications are geared towards running in Docker. The vast majority of projects already have a Docker image available. You don't have to do anything else. You just kind of pull it and run it. Whereas with Nix, the Nix packages repo is great. There's like a lot of packages, but you might run into things that aren't there, and you might have to manually package some things yourself. We'll get to some ways to get around this later. Also with Docker, it ends up encouraging you to leave Docker Compose files all over your system. You might set up one project, and then you want to set up another service, and that's going to be in some other folder. But Nix, you kind of get this benefit for free, where all your configuration is in one place. Also with Docker, versioning is opt-in. You're kind of relying on whoever's maintaining your image to make sure to tag it correctly with the right numbers and everything. Whereas with Nix, you get this for free as well. It's super easy to roll back, as we just mentioned. Also, Docker is not really tied into the rest of your system, whereas Nix is. You can basically control almost anything on your system with Nix. So, also on the topic of Docker, you don't have to choose. You can have the best of both worlds. So there's Nix options that actually let you start up Docker containers, on boot, and also you can pin Docker images to use a specific hash. I ran into a use case where I was using trying to get this photo backup service called the image setup. And unfortunately, image doesn't have options in the Nix options. But it has a working Docker Compose. So I took my Docker Compose, and I used this really cool utility called Compose to Nix. You can find the GitHub over there. And I ran this on the Docker Compose, and it generated a fully working Nix file that would just spawn up that same Docker container. And this was great because I could just integrate this Nix file into the rest of my system and not have to worry about random Docker Composes all over the place. So I highly recommend you check this one out. Okay, so Samir, can you tell us how Nix stacks up to Ansible?
Sure. A lot of sysadmins commonly use Ansible to try and achieve the same things that Nix can guarantee. But there's a lot of downsides with Ansible. The first thing is that if Ansible does something wrong or something breaks when you're using Ansible, it may not always be possible to go back. For example, you can't really undo an OS update with Ansible, whereas Nix has rollbacks built in, and it's completely free with Nix. Also, Ansible will it'll do its best job to take you between states, but sometimes it's impossible to go from one state to another, and you're relying on other people to have built mechanisms to do that. Also, Ansible is notoriously slow. Every time you run it, it'll have to check a bunch of things about your system. Whereas Nix is lazy, kind of like me. It'll only do the bare minimum to rebuild your system and take you to build whatever system you want to make. If running Ansible stops in the middle for some reason, for any reason, it could break your system since it's just modifying things directly on your system. Whereas Nix builds are atomic. Nix will be writing to the Nix store and doing whatever work it needs to do, but when you switch systems, the symlink switching is atomic. It'll happen instantly, and you can't break. Nix is not going to update programs while you're using it. It can't break whatever's running. And it's easy to drift away from Ansible state, because Ansible will allow you to just run arbitrary commands on your computer as usual, whereas Nix limits what you're able to do, and it's going to be controlling things using symlinks to the Nix store. So Ansible is trying to bolt on determinism and declarative environments when your OS really isn't that reproducible. But Nix is locking things down and making sure that things are going to behave as you expect. So we've been talking about the good parts of Nix, but there are some rough edges. For example, the Nix packages is just made by everyone. Anyone can contribute. So there may not be options for everything you expect. For example, the open firewall option isn't on every single package, which can be kind of annoying. Also, the Nix user base is not that big compared to people who use containers, so there's less documentation, which can be kind of hard if you enter an edge case. And this is definitely not helped by Nix's confusing error messages. Also, when you do find documentation, Nix's community is currently split on whether to adopt this standard called flakes. So finding documentation with the different standards can be kind of confusing. And Nix's line of thinking works a little bit differently. There's a little bit of friction to do everything, but if you do use the Nix way of building your system, you're going to eliminate a bunch of problems. But in summary, is Nix better? Yeah, I would say so. Nix is freeing. You don't want managing any server to feel like your full-time job. And configuration.nix is completely self-documenting. You're going to get an overview of all the system state in one place, and you don't have to worry about breaking your system when you make changes. So let's take a look at what Nix offers. You get fearless modifications with rollbacks. You don't have to worry about your system breaking because you can always go back, and it's going to happen. Rollbacks are pretty much instant. Configuration.nix is just a text file which anyone can read. I can read anyone's system config and pretty much figure out what's on it. And with reusable components, you can reuse work that other people have done, and you don't have to worry about the quirks of setting up every single system package you want. So you definitely should try this at home. If you follow this link, you'll come to our GitHub page where you can follow some instructions for setting up your own server and following what we did basically in this presentation. You absolutely should try this, and if you want to get your friends to use Nix, this is a great place for them to start without, I don't know, killing their own laptop by installing NixOS. But yeah, using Nix is a vote for the future of declarative software. And with that, thank you for attending our talk. If you have questions, you can ask them now or later in the hall.
On the far right.
Right. So the question was, how do rollbacks work for when a program has some state on your file system, like databases? So a Nix rollback cannot handle that case, because a Nix rollback is not going to affect the database files that are on your system. So if a program's checking, if you upgrade your program and it's going to do a schema update to version 2, when you roll back, the program's probably going to check that the version is not above whatever the program is currently running. So the program will probably just crash or not work. So it's just on to you to make backups of your own user data. Any other questions?
In the back.
Sure, yeah.
Yeah, the question was, one benefit of Ansible is that you can easily work with remote systems, and how does Nix compare in that sense? Well, there were a lot of great talks at NixCon. I think, was it today or yesterday? I think it was today. There was a talk on like how to remotely build for a remote system and deploy there. So there are ways of doing it. I'm not too familiar. My method of remote deployment is SSHing into my home server and running NixOS rebuild. But I'm sure the community has come up with like great ways of deploying to remote servers. Yeah. Yeah, so it's pretty good support. Yeah, over there. Yeah, so the question was, how does the Nix style of snapshots stack up to block level snapshots like ZFS or BTRFS? I'm not too familiar with ZFS, but I've worked with ButterFS in the past. I've kind of alluded to earlier, the main difference is that Nix doesn't manage or snapshot any user data. It only really touches your application and service binaries and the config files that it manages. But if you have any user data, it won't touch it. Whereas with like something like Btrfs, all your snapshots will include like all your user data by default. There's ways of like ignoring that, and you have to manually set that up. But by default, Nix won't touch any of that user data. So yeah. Okay. Thank you so much. Yep.
All right, thank you. We are going to take just a minute break while the next speakers get set up, and then we will be on to the UnConference. So the UnConference, we will meet in here, and for those of you who have no idea what that means, basically here's how it's going to work. We will, if you want to talk about some topic with some, anybody else here, you'll come to the front, and we'll just like make a list of topics, and then we'll have some voting mechanism to see which topics are like most interesting to most people, and then we'll just break out into groups, either in like different corners of the room or out there or wherever there's room, and then you just talk about whatever the hell you want to talk about.
So pumped. I don't know how to use it though. Oh, okay. Test. Test. I heard it. I was quiet about it, but I heard it. Yeah. Sorry. Yeah. Is it okay if we both have one so we don't hand off the microphone, or? Okay. Maybe on the side, but be able to. Yeah, it'll help you to stay visible, and you can hit the next button. So, yeah, I think so. I see it says mic. Should I flip it to that? Okay. Testing. Test that up.
Test, 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 test. Okay. Hello, everyone.
And I'm testing this one too. Okay, good enough. Good enough.
All right, I want to thank everyone for coming to our talk. The talk is called High and Low Lights of Adopting Nix at Looker. And the rest of the talk will make clear what this is about. Reset my time.
Just use a button.
I know, I just want to. Cool. So our goal really is not to wow you at all with the setup that we're about to talk about. And it's not exemplary in any way. There's nothing fancy about it. But really, it's to highlight what I would expect to be a very run-of-the-mill use of Nix, and maybe to encourage you to adopt Nix at your company. So, like, that's the goal. You're not going to see anything mind-blowing here, nothing shocking. In fact, probably a lot of the same stuff you might have just heard in some previous talks, but we're doing it in an enterprise setting, and we found doing the most boring, flavorless thing proved to be pretty useful. So that should be words of encouragement for you, because some of Nix can be pretty daunting, and even without all that stuff, it was a boon. Yeah, an interesting product. So yeah, we work at Google. We'll mention that in a sec. They have a huge sizable team that works to build amazing tools to improve the developer productivity. We came in through an acquisition, which we'll also describe. We didn't have access to any of that. So we had to kind of fend for ourselves, build a CI system, developer experience that we wanted to use that was actually friendly, and kind of like that's what this talk is geared to. Obligatory. Our opinions are of our own and not of those of our current overlords, Google. Finally, this talk is going to have high and low lights. Our hope is to be fair. It's overall a positive talk, but we're going to just share some of the sharp points we faced adopting Nix. You can jump in anytime.
Yeah, let me just add one thing to that. Frida already mentioned that the team we're working on, Looker, is a standalone product that is hosted in Google Cloud, but it doesn't build with the same technology stack as the rest of Google, and we don't have a dedicated build tools team. So the same engineers that are working on the JavaScript front end and the JVM back end are the same people who might work on the build. So we needed to have some sort of situation where we could control our own destiny and solve problems that couldn't get solved in the central places because of the exceptions we had to be using. So anyway, this is good because a lot of you guys are probably also in companies where you don't control the entire build chain from the beginning to the end, especially if you're split up, in different sub teams or an ops team and a building tools team. So anyway, that'll be a central theme.
Cool.
Yeah.
Why do we feel privileged to give you this talk? So first of all, my name's Fareed Zakaria. I'm an engineering manager at Google working at Looker. I've been using Nix, I don't know, 6 years, 7. It's honestly on and off because it works really well. So I'll set something up and not touch it for a year. So I've been using it for a while, but not actively all the time.
Yeah, and my name is Micah Catlin. I'm a software engineer, and I've been working at Looker for a really long time before it was acquired by Google. So I'm partly responsible for some of the terrible hacks that we now are committed to.
Okay, so I mentioned we worked at Looker. It's a SaaS business. It's a SaaS business intelligence product that works very, 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 very well with BigQuery, along with some other big databases, but primarily BigQuery, which is not a shock. Honestly, Looker itself is not really important to this talk. We're going to really talk about the technologies we've used and how we used Nix to kind of bring on a developer productivity or improve developer productivity and the CI. But just some background, it was a startup founded in 2010. It was originally written in Ruby, and it has grown to become a very large monolithic code base, mostly JRuby. It has quite a sizable portion in TypeScript and a growing number of files in Kotlin as well. Originally, the developers were mostly working on macOS. CI system was on Jenkins, on Linux. Since the acquisition, we've all had to migrate onto a Linux distro kind of managed by Google. So it's just, it's like Debian-based, but not really. Cool. Yeah, so that's kind of just on the slide. You'll see just the mishmash of different technologies we had to support. This is important because we needed a tool that didn't just work really well for Ruby, a tool that didn't just really work for Kotlin, so we had to solve how do we solve everything? And at the time we did adopt Nix, we had some influx developers working on macOS as well. Cool, so this was a slide that I actually developed when I tried to sell Nix internally at Looker. So this is a very, very, very old slide. The text isn't really important. You can't even read it, oh God, on the right there. Okay, it's just from the README of our internal repo, so it's probably even better that you can't see it.
That's like page 1 of 20.
Yeah.
Yeah.
Page 1 of 20. It had actual code snippets you had to copy and run. So it was a very complex README, bunch of steps. It had a choose your own adventure style. So it wasn't do this one thing from 1 to 20. It had branches because, startup people bring their own opinions to things. So people wanted to maybe use RVM or RBenv. So those are different Ruby version installation managers. So I don't know why we wanted to support both, but we did. Same thing for Node. So it was pretty complex. You needed sudo at a lot of points in the script, which made it a bit crazy. And really, we didn't have any metrics for this, because why would we? But it took an average developer anecdotally about a full day to go through it with a lot of hand-holding. You know, startups we had a Slack, it was a lot of engagement. People would run into whatever kind of like error from the day, and someone would help them, and it was, people were really engaged. And to be honest, that sounds like a bad system, but it worked for like 10 years. So, you know, because it was a small company and everyone was like really into it. So yeah, it kind of worked well enough. So I don't know, the engagement was almost like a feature and not a bug of this like shitty development process. So yeah, I just wanted to kind of highlight like this kind of worked. Like it was really bad, but it worked. And it had like enough collective fixes on all the scripts to account for all the like weird edge cases people ran into.
Right on. Okay, so Fareed did a lot of work and groundwork to research Nix. He kind of liked it for its intellectual purity. He liked it for all of its nice properties. And he kind of socialized within the team that like we could use this thing. It's mature enough for what we want to use. And at some point, we got the go-ahead to staff a small project for a bounded amount of time to accomplish something. And so I was a member of that effort where we just had a couple of months where we were going to do everything we could to like bring our build system forward and meet some of these goals. So we had a goal to like make sure that our CI system and the developer workstations were consistent. They were very much not before we started. We made a goal to speed up that developer workflow for like actually starting when you have a new developer and getting through that README faster. But we stopped without setting the goal of making the product itself be built by a Nix derivation. So we really invested in setting up a Nix shell environment that could replace the developer workflow in which we could build our product. And then we left open the door that we could continue this work in the future if we want to go ahead and make a derivation that builds our final artifacts. But we went 2/3 of the way through this set of goals and declared success because we had actually delivered a lot of value there. So next slide is going to just show kind of what we did on each of these goals. I'll verbalize it because I want you to have in your mind what we did before we go through all of these highlights and lowlights. So step 1A was that we set up Nix shell, a shell.nix that pulls in all the dependencies that a developer needs to run the build, as well as durinv, which manages setting the path whenever you switch in and out of that directory. It pulls in all of your Nix store paths and then throws them away when you leave. So it's a really fast in and out. Then the second bullet there is that we put this block of code in our CI jobs so that they also pull the same sort of Nix shell environment before running any of our legacy scripts. This is a big deal because we didn't want our users to really even necessarily know that Nix was happening, because there's like 100 developers. They don't know. We don't want to teach everybody the workflow of Nix at once. So we try to make this as invisible as possible for those users. All right, then the next big category of speeding up the developer workflow, that was a huge success because it used to be that everybody's developer environment started by downloading a JVM, downloading some version of JRuby, some version of Node, some version of NPM, installing all the dependencies that are driven by NPM, installing all the dependencies that are set by your gem file, installing all the dependencies for Gradle. There's just like this long list of work that happened on entry into a developer environment. And now all of that gets done by a CI job that populates a binary cache. So an engineer, when they like boot up a new cloud top, change into their directory, it just pulls down a bunch of binaries from a local bucket, and they have a shell within seconds or maybe a minute the first time. So it really did speed that up.
One day down to a couple minutes, pretty good.
Yeah. So as a percent speed up, it was like kind of a nonsense number, but like a thing that used to take all day now is something you can do routinely. Yep.
Okay, so things become a lot more interesting when you consider CI jobs. I mentioned we work at Google. Like, there's always some crazy bazillion flop numbers that are attached with that company's name. I wanted to give a sense of scale. Like, we were a startup, got acquired. What was the scale of the number of CI jobs we wanted to support? Like, the system had to support that. So this is a graph. It is, I don't know if you guys can see the number. I'll just tell you anyways. It's about 1,500 pre-submit, which is like the CI jobs you want to run on code review. We have a bunch of other jobs as well. They're not included in this graphic. So that's the median. And
the concurrent CI jobs.
Concurrent CI jobs. And it's a pretty bad median. It's across like the whole month or whatever that time range is. Obviously, it like dips on the weekends because we have lives and we don't like to work on the weekends. But that's kind of the scale we were working with. And to be honest, that scale, we did hit some roadblocks. Like, you know, I don't know if any of you were here yesterday trying to do the Nix Install Fest. You know, there was quite a lot of issues just downloading from GitHub and hitting rate limits. So we hit a lot of similar issues at this scale. So whatever you hit with 100 people, at 1,000, you kind of hit a little bit more. Yeah.
Yeah. So we leaned heavily on those binary substitutors, and Nix already had support for using an S3 bucket as a cache, and Google Cloud Storage has a mode where it emulates S3. So we set up a bucket that manages all of our binaries, and that thing can scale to any amount of traffic. So it doesn't matter if 1,000 CI jobs all boot up at once and all pull down the Nix packages archive, and they all pull down a JVM that's hundreds of megs, it's fine, right? GCS or S3 can scale to unlimited reads, really. So.
Yeah, one last point, our security posture means we cannot use the public Nix cache. So we had that disabled, which is maybe also a good thing, considering, I don't know if you guys were at the State of the Union talk and the cost of the Nix S3, to support the S3 cache. This slide, we could probably do this pretty quick. It's just like a timeline, just to see like what did adopting Nix kind of take at our smallish, medium-sized company. It was like a 2+ year. It starts at July 2020. That's kind of like the research phase, looking at like, can I even adopt this? A lot of hand-holding, a lot of white glove, mocking things out, kind of like tool by tool, getting slow people. Honestly, like the implementation part was pretty slow, quick rather. It was mostly the big problem was socializing it. So like getting buy-in, getting people to know what the heck's changing, like should we adopt this thing that's relatively niche? Yeah, and kind of like a final notable mention is a big problem point was I was trying to support macOS and Linux at the same time, and that was really hard. Like, and I'll talk to why in some of the lowlights, like some packages just became really difficult to support on macOS, notably Chromium, and which we had to pull into our graph. Okay, we're gonna get into the highlights and lowlights. This is kind of like the highlight is we did some pretty boring Nix. In fact, like we were talking, me and Mike at the hotel after having listened to some prior speakers and thinking we could have done actually a lot more fancy stuff. We didn't use any modules, it's not very like reusable. It was, what am I showing here? Like a shell. I mean, we went a bit fancy, and I don't know if you could read it. We used the like no CC, so it's a little smaller. I mean, it's a shell with some build inputs, couple of custom derivations, but like, that's it, really. So in terms of like fanciness, it's pretty low.
Yeah, but the thing about us was that you probably can't read it, but the return value of shell.nix needs to be an attribute set. There's a few attributes that name binaries that get pulled in and set in the path, and then anything else that you set as a value there gets converted to an environment variable. So this let us control the environment variables and the set of binaries in the path for the developer workstations. So it meant that like every engineer, whether they installed their environment today or 6 months ago, or if it was on a Mac when we were trying to support that, they would all have the same version of the JVM. They would all have the same version of Node, et cetera. So just being able to control the environment variables and the path and the binary path of this Nix store was enough. We don't need containers. We don't need virtualization. Yeah.
Simple primitive, highlight. Okay, in 2020, we chose not to use the experimental flakes feature. And we didn't find it an impediment in any way. That's kind of like what I'll say on that topic. There's a lot of back and forth on it. I don't know. We just stayed out of it. And it was a highlight. So that was a quick one. You want to do that one?
Right, okay. So here's another good and bad. We're calling it a low light, but it was so easy for people to add the name of a package to this one source file, a text file, and then every engineer would have that binary. It made it really easy for this democracy or chaotic team to like pile in everything. So pretty soon people are like, wow, I would love to have Chromium in my build. Oh, I would love to have an IDE in my build, whatever. So this thing grew, and the closure over all the things that gets installed got to be pretty big. So it was too easy to add things.
Bit of a Pandora's box that we got open. Okay, this one is like, I would give tech talks, and I'd explain what Nix does and how it gives you near perfect repeatability, reproducibility, whichever one you want to say. And some of the engineers, their takeaway was pretty good, and they'd come back to me and be like, great, like I want now Node at whatever, some very specific version, and I want another one Node at this other version, and I want it with this patch, and I want it to link with this other version. And they're explaining stuff to me, and they're not wrong. Like, that's the problem. I spent a lot of time explaining to them that Nix can do anything. So they come back to me, and they're like, now they want the world. And I'm kind of like, fuck, like, you can have it, technically, but it's just me and Micah, and I don't want to do this. So the goal was to really have one Nix packages for our sanity that we pulled from. And if we wanted to do all this other stuff, it meant really blowing up our transitive closure. So like I'm calling that a low light because I don't know, I'm still grappling with like how to tell people to adopt this thing without them coming back and saying like they want a bazillion things at very specific versions. You know, I guess the good part is you could give it to them, but I found it an impediment.
Sure, yeah. So, okay, this is good and bad. We've repurposed an art that you've probably all seen before, but the issue is if you declare a dependency of a package that is defined in a particular Nix packages, and then later another package at another version is introduced, that thing may depend on different libc, different other things. So if you go ahead and try and pin like an old version of Ruby, a slightly old version of Node, a pretty modern version of Chromium, then you end up with like a really big binary Nix store. So it got really big.
Yeah, another lowlight was, you know, again, I mentioned we tried to keep it to one Nix packages, but we had to deviate it a lot of times. And what was also frustrating, many of the recipes aren't really reusable. So we needed to tweak, unfortunately, a few things. And it just, you know, we tried to contribute upstream changes so that those recipes were more reusable so we can adopt them. But I'll mention later, us pushing, moving ahead on Nix packages was kind of a challenge. So we had to often just copy out a derivation. So there was like a bit of repetitiveness in our overlay and Nix packages, which was also a bit of a low light. So that's kind of the, Nix packages was like huge and sometimes unwieldy.
Yeah, okay, another issue is we don't control the whole shipping environment of our product. In our team, we were kind of asserting control over the build tools and the developer experience, but another team manages the Kubernetes deployments and the Docker container images and the way they get tagged, and we didn't have like end-to-end control. So we basically use Nix to set up the build environment. We build our binary artifacts within a Nix shell that's under our control, but then another team has their own processes and their own culture about like using Docker container images and GCR and whatnot. So it's funny, like we wanted to replace Docker in our development environment, but the operations team absolutely had no interest in that at that time and no appetite for it. So we kind of like, you could either use Docker to build Nix or you could use Nix to build Docker, but we ended up with like two teams each using it in the opposite direction. And that's a cultural problem. It's not really a technical one.
Yeah, that was an interesting learning lesson for me is shipping software is not always technical. And you know, we've seen Docker tools in a couple of previous slides here that you could build layered images. But they wanted to build their own Docker image, like they being this other group. And it's like, how do you get past that organizational problem? I don't know. We're still pushing past that. Okay, I'll do this one. It's a quick highlight. And I couldn't get a benchmark. So the top one's a benchmark of what our Nix shell took. It's like 6-7 seconds. That sounds good, but that's just like really long time. And you know, what typically normal developers are accustomed to changing a directory and it just being effectively instant. So 7 seconds, they felt like something's going wrong, and maybe worse if for whatever reason it starts building the derivation locally because it's not in the cache, or I don't know. They're the first ones to ever hit it. So like direnv was effectively a necessity. Like I can't see anyone adopting Nix shell at their enterprise and getting people to use it without that as a complement. So yeah, I don't have the benchmark for it, but it's like as fast as a race car, near instant.
Yeah, let's just briefly explain what that does. When you run Nix shell, it parses Nix shell.nix, builds the closure, checks for things in the store. All of that work took 6 seconds to do it once. So every time you were to like start a new terminal and enter into this shell, it's taken 6 seconds. So that's no good for a workflow. And direnv is another tool that sets up a shell hook so that when you enter a directory by typing cd and the prompt displays, a side effect of evaluating that prompt is direnv runs a shell script. That shell script takes a snapshot of the environment variables from the last time you were in that directory and restores them. So it means that if you have ever entered the Nix shell, the first time takes 6 seconds, but then any other time when you exit the directory and come back in, it's just changing some environment variables, and that happens like near instantly. So this is like, you lose the little bit of fidelity of your closure because you just have the environment variables, but it's totally enough. So that made a workflow. The workflow is great. Right. Okay, cool. Here's another thing. Nix actually stores some state in your home directory and in a database in the store. And not everybody knows like which environment variables might affect like the combination of the final calculation of hashes that become a cache key. So we just wrote a script that like installs Nix on your machine, and another script that blows everything away, including all the subdirectories where we know that Nix keeps state. And then that way, whenever an engineer says like, there's a problem with my build, it's not hitting the binary cache, we'd be like, no problem, just run this script. And it would solve the problem. So it's like, it's a big hammer, but like, it's so easy to go from 0 to having a particular Nix state that it's okay to just throw away the state and make it again. So I'm calling it a highlight.
Okay, this seems like a simple one. Again, like nothing shocking in any of this talks, or our talk, but having the hash name, like those like squiggle, the cryptographic part of the name there, incredibly powerful. Like it made triaging issues with the other engineers very quick. I could just ask them to like, tell me the path, or tell me like, run the command which, whatever, in this case it'd be Ruby or JRuby, and I'd see what they see. If it's different, I already can like take branch A. If it's the same, I've already skipped a dozen steps in my mental model of whether or not they have the same software as I do. So that just like that visual cue, huge. It also gave us a lot of confidence that the CI system was running the exact same software, and it was in fact hermetic. So we would emit the paths that we were running Ruby or Node, and know that yes, we're running, or the final closure, and know yes, everything's the same, and it didn't pick up some random NixConf, setting, or we forgot to set maybe, we were using like, anyways, yeah, there's a bunch of different like idiosyncratic ways which you can leak out some state.
Okay, let me take this one. Because Looker is an enterprise software, we ship a binary to some customers that they keep in the field for years, and then maybe years, and then other customers that we're giving updates every month, every week. So the fact that we were able to have our toolchain configuration checked into our same source code repo where our source is at means that if you need to make a small change to a year-old release branch, you just change that branch, make a patch, and all the binaries that go with that build are also in your path. So you don't have to remember that, oh yeah, that old version from a year ago only runs on an old JVM with a patch, right? Because when you switch your dev tree, shell.nix has that pinned Nix packages, and that's the JVM you get. So it made it like actually possible for us to keep building old branches long after, like even maybe if the source code that we needed from an upstream thing was gone, not hosted anymore, we could still build because our Nix binary cache is durable. So this was a huge lifesaver for supporting old release branches.
Yeah, this slide's made a rounds a couple of times, or at least twice, I think, in NixCon today, but few people understood Nix, okay? I gave like, I don't know, a dozen plus talks at the company and at broader Google, and I don't know what the acceptance rate was of like what I was saying to what they were receiving. It'd be like under 10% for sure. And this graphic, which was shown a couple times, just a bunch of stuff about Nix doesn't lend itself to become easily understood. I'd say the word Nix, and right now it's like, what am I really talking about? I guess I'm talking about really all of it. And then if I wanted to talk about just the language, I'd say Nix. So yeah, it continues to be confusing, and since adopting Nix, really, we haven't seen much increase in contributions from a few key people. So I think that's something to keep in mind, and I guess that was a low light. Some things we called out was like lack of good IDE tooling. I know the language gets a lot of flack, and it's not that bad after I've used it for quite a while, but having someone jump in, and it's difficult to navigate and understand the type system and find where things are. Yeah. I'll take this one. Okay, this was something I hit because I said we kind of hit like some edge cases here. So it's a bit of a snide comment about a real problem, but basically missing source files for particular old Nix package versions such as patch files, could go missing. And large packages such as Chromium, are repeatable. So you could build them, but I couldn't build them on my machine. Like sometimes you'd need a massive machine to build it. So it's like, great, I have this recipe to reproducibly build software, but on whose machine? Like on the Chromium guy's machine, he could build it. I can't build it. And I know Nix Cache does cache some of the source files itself, but I found a few cases where some patch file would go missing, and you get a 404. And it's like, okay, that's like, well, how do I rebuild this now? We were kind of in a sticky spot because, again, we were using a very old Nix packages, I don't know, over a year. So, yeah, and we couldn't use the public cache. So we were building things from source, relatively old, and missing some source files. I have certain environment variables were also found to have an effect on the computed store hashes. So we found like sometimes some developers would also miss the private binary cache that we rely on. Okay, I mentioned this one a bunch, but basically updating Nix packages, like I hated doing it, and I tried not to do it at all. I would never, I thank the release managers so much, but like that's an incredibly tough job, getting all Nix packages to pass. I don't know what we're at now. Like I look at that Repology graph, if any of you have seen it, it's like 80,000 packages in Nix packages or something like that. And like I said, when you have access to that, you just want to use more and more and more of it, so updating it. And then if you deviate a little bit, it becomes hard, so it was hard. So I resorted to using a few, I think we have like 3 or 4 Nix packages at different commits there. That turned out to be the easier problem, but it would pain me so much time, when I would do that. So yeah.
Yep. Let me take this one. The picture shows basically the 3 nesting dolls because we had these abstract environments that we only controlled between Fareed and I. This is the middle one. On the outside, we have this G-Linux distribution that another team controls. We control the Nix shell of our build environment. But then inside our Nix shell, we run other build tools like npm and go out and get things that developers have declared dependencies on. So we were able to like grab intellectual control of that middle layer and deliver a huge amount of value for it. But like the rest of the nesting is like still somebody else's domain. So it's a highlight because we were able to like actually work and add some certainty to that middle layer, even without controlling the outer layer. We also got to do this in our CI jobs that we don't have root on the CI machines. So being able to install user space binaries in a controlled way, super big highlight.
I think it's also a highlight, like the developers didn't have to change their workflow. If they used Bundler or Gem or NPM, that stuff, pretty much worked. And as Z would say, asterisk, like there was some finer points, but for the most part, they didn't know they were using Nix, and that was a highlight.
Yeah.
Okay, this is one of the, maybe the last slide. I'm calling it a low light. Like my experience in Nix packages and ecosystem was like mixed depending on which path you take. So like not all languages and frameworks in Nix packages are created equal. It is an open source project. So it's like subject to contributions and what's there and passion of the developers that are contributing to it. So I found like C++ and Haskell, phenomenal. Like, if you want to build a Makefile project, like you're not going to have a bad time. If you're doing Haskell, I don't really do Haskell. It looked phenomenal there too because there's a lot of overlap with Nix. We were doing Java. Like JRuby is built on Java. Like there was the JDK there, but it had a lot of bugs. There was like packaging a Java app. I wanted to look at it. Not really supported well. Had a bunch of weird kookiness to it. So like, yeah, that was, I'm calling it a low light because I didn't know that going into it. It kind of felt like it had everything and some panacea, but nothing ultimately was a blocker. And I upsourced a bunch of changes and fixes, so that part was a highlight. It just meant, like, be mindful about which path you're taking and what language you're doing. I think see what's out there and yeah, know what you're doing. I can read some of those to-dos.
Right.
This is like, we have a bunch left to do. It doesn't matter if you can, I don't even know if you guys can read what's on the screen, but like we mentioned, we have a bunch left and we got a ton of value. So like even with all this laundry list left to do, what's some of the stuff there? It's like
Probably the big thing is getting Nix and Bazel integrated. Like the talk we saw this morning was really, or earlier today was pretty great because we also use Bazel in our build, but we use Nix to install Bazel and control its environment. And I know it's possible to invert that relationship, and it's a different thing, but we would like to continue that and get all the way down to the end of those leaves.
And maybe overcome that organizational problem, get them to use like a Docker imagery build. So there's like a bunch left, you know, finally get Nix packages on the latest release, like things like that. But yeah, still huge benefit.
Yeah, that's the point. Like even though we only got halfway, it's still valuable, and the team values it, and it works every day, and it doesn't crash.
Cool. That concludes our slides. Happy to take whatever time we have left for questions here. Otherwise, please find me or us. I'll take a couple, or we'll take a couple. You got okay? Couple questions? Oh, okay. We'll start at the front.
So, did your developers ever get asked just like adding things like build in questions which tools they wanted, or did they ever become like Nix fluent?
Okay, so you asked if the developers got Nix fluent, and I would answer basically a few. There were like 2 or 3 people who like needed to upgrade a package and then had to get deep into the recipe to make it work. But most engineers, they just got trained to like type this one command, and then your shell is good.
It's 2 out of 100. So take that as your percentage.
Yeah.
Okay. You and you. Point at yourself. I don't know. Yeah. Yeah, that's a good question. The thing we did had to articulate is it's a pretty simple solution because it's all environment path based. You had to start your IDE in the Nix, like in your current working directory. Yeah, so, thank you. How did we solve IDEs, integrated development environments or text editors, to use all this like fancy Nix stuff? And basically, as long as you start the IDE within the shell, within the directory you're in, it picks up the environment as a sub-process, so it'll find all the tooling from the path Nix sets up. The one hiccup here is if you change to a really old branch where your path changes, like you'd have to know to shut the IDE down and reopen it. So that was a bit of a pain point, but otherwise it worked pretty well. Over there.
Yeah, I guess the short answer I can come up with, he asked what happens if the few experts in the team that know anything about Nix, if we're all gone, then how would the company continue? And the short answer is that all that code is checked in. It's in our repo. The CI system, will not allow you to check in changes that break the test. So like somebody will have to figure it out. Like,
I can guarantee it'll keep working. Like that's a selling feature. It won't degrade. It may not get better, but to answer your point, like seriously, like, we haven't seen much more adoption in terms of people using it, but also we haven't had to change it much. So like once it's hit stability, the big thing's been keeping Nix packages up to date, and yeah. Okay.
This guy in the brown pants. You guy in the brown pants. I saw you had your hand up right away. Yeah. Yeah. Yeah, so the question is like, how do we avoid accidentally depending on something in our build environment that's provided by that G-Linux layer, and then breaking the hermeticity? The short answer is that our CI system doesn't run on G-Linux. So if you ever introduce some shell script that like makes a call out to some awk binary that is absent from our Nix closure, then that will fail the CI jobs that try to build the Nix closure. So.
Yeah, and just to be clear, we're not in like Google's mono repo thing or any of that. So we're it's a separate Git repository, so that also helps. Okay, we'll do 2 more. You with the white shirt, the NixCon shirt, yeah.
Okay, he's asked about the Nix Bazel integration. The short version of it is our Nix environment installs Bazel, and it also downloads all of the HTTP archives that we know that our Bazel workspace file references, and it puts those into a directory so that the first time you launch Bazel, it has a JVM, it has all the Starlark rules it needs, stuff like that. But then Bazel just drives our regular Java build and produces all of our JVM artifacts that then get wrapped up by shell scripts.
Yeah, I'll just add the part it really shines for me is Bazel and tool chains is like their tool chains. If you've used Bazel, their tool chain solution is pretty terrible. That's a personal opinion. So it's a great way to bring in like if you want Clang, the JVM, whatever. It helps that tremendously. Last question, Mask.
So I want to say the solution that y'all came up with of just using the shell and everything, really genius. I tried to get Nix adoption from other previous employers in different environments, and it's interesting to hear that'll work great for y'all. I'm curious, can you elaborate a little bit about the difficulties that you found with, you mentioned that Java, Ruby, JRuby, you had difficulties with. And I would actually expect that, I would expect that from like trying to build something as a derivation. But it sounds like y'all are using that for shell. What were the sort of
Yeah,
Can I take that one?
I'll do a simple example. It should be pretty quick.
Restate.
Sorry?
Restate the question.
Oh, restate the question, frick. Okay, yeah. What are some of the issues we ran with JRuby, Java? You would expect that maybe with building derivations, but not with maybe a Nix shell. The one that really comes to mind is the Nix package contributors have done a really good job cutting away like system state. Like, so, I don't know, the loader is patched away so it won't read user lib, like shared libraries, things like that. So there's a lot of like patches to make things so they're hermetic. The JVM was missing a few, and they would come to bite you. So if you had to use Java can do native interfaces and link to shared libraries, I found it linking to like a different libc, and then suddenly you're hit with a seg fault. So nothing like we couldn't get over, but you're just, again, it's like those two paths I showed in the slide, like, oh God, like, why am I hitting this error? And it's like, you know, you're trying to triage it. So it was mostly shared object calls and, yeah, path leakage. Cool. We only had, anyone else has questions, please find us at the UnConference or outside. I'm Fareed, and that's Micah. Thank you so much.
Hello, cool. So, time for the UnConference. So, as we get started, I need 2 volunteers. Raise your hand. You and you. Great. There's a whiteboard out there over by room 106. Go grab that and wheel it in here. We're going to need that for voting and stuff. So, like I mentioned before, the way this is going to work is that I'll open up for a few minutes to let you come write up topics that you think people would be interested in talking about, or selfishly that you care about. You'll come up here, write those on the board. I'll let that run for a couple minutes. When I close that down, then I'll let everybody come up and put a little tally next to 2 topics that they care about. So you get 2 votes, all right? And then we'll just take the top X number of those topics, break out into different corners of the room, and you guys can just go ham on whatever you're talking about, all right? So that's how it's going to work. At 4, I need to go somewhere, so somebody else will have to be the adult in the room while that happens. But yeah, so that's generally how it's going to work. This is intentionally very unstructured so that you can just kind of talk about whatever shit you want to talk about. That's kind of the whole point. So I'm just going to keep riffing until a whiteboard comes in that door. And yeah, here we go. Sounds like the whiteboard is off-roading. Cool. You mind watching out for a second? We're going to get this around. Yeah, let's grab this. Oh, beautiful. Cool. All right, let's rotate it the other way. Rotate it the other way. Cool. All right, so I'm going to open this up for, let's say, 3 minutes for you to come write whatever topics you want up here on the board. And then, like I said, I'll close that down. Then we'll let everybody vote twice on the topics that they care about. And then we'll just take it away from there. All right, something I forgot about is you may not know exactly what somebody means by what they've written on the board. So once these are all in, I'll let people give like a 10-second explanation of what their topic is about, and then we'll do the voting. Hello, hello. All right. Get our last topic on the board. All right. So, now that all the topics are on the board, if you'd like to come up and explain 10 seconds about what your topic is, if it's not self-evident, the time starts now. Speak now or forever hold your peace.
Greetings, I'm Micah. I'll be taking new user questions and answers. If you feel like you didn't get enough or missed the session yesterday, Tuesday, Thursday? Yeah. If you're new to Nix and you want the basics, come ask questions and maybe you'll get answers.
Anybody else need to explain their topic? It looks like, yeah? Yeah?
So, module system. Testing, testing. Okay. This is always hard. So, module system. I like it a lot. It's really nice to use. Has a whole lot of application. I think there are 2 presentations, and I still think there's so much more you can do with it. But it's hard to debug sometimes. I'd like to talk with others. Oh, do you want to talk there? Okay.
So I need help because I run Linux on my calculator. And since I used to use Arch Linux, and since that went end of life, it is no longer available. So now I'm looking at Nix as a viable option for building Linux on a calculator.
Would you mind writing this like down here so it's not right next to this one?
It's the same thing.
Gotcha.
Yeah.
Cool, cool,
I
cool.
gotta help. I need help with crosstalk as well.
Yeah.
Hello? Okay, so immutable NixOS appliances, systemd people like to call that image-based Linux too. And contrary to traditional laptop Linux installations where you'd have an install medium and then bring in all the software yourself, in that case we actually prepare a whole operating system image in advance and deploy that to some server. But generally, I would like to talk to everyone who uses NixOS in server-based settings and hear about your problems because we as a company too are trying to work on a lot of pain points there currently.
Hello, I just switched jobs, as you can tell by the hoodie. I'm trying to use Nix at work. So I put 2 topics actually. One, if anybody's used it in production, has the war stories, the 4 a.m. wake-ups, the getting paged, all the issues, especially if you're on Kubernetes. Want to hear all the issues. And then if anybody wants to talk about using Python well with Nix, would love to hear that.
All right, before we open up voting, Ron has a couple words to say.
All right, so I don't know if we're going to be able to congregate back for a closing note, but we'll leave the survey up. We'll try to email the survey out as well. In general, yes? Yes. What's a Google form? Yeah, so I don't know if the Google form is that. Oh, okay. So that's a determinate system survey. But good call out. If there's other surveys, there's the survey, the first one is like the official survey for the community. It's going to be published publicly and all of that. So please fill it out. It helps us for next year. Other than that, there will be an option for folks that want to get a quick picture together for the conference, only those that want to, up in front together. That's something that we do every conference. So before we do before we break for UnConference, I'd love to do it. And last note, a lot of folks might not know, there's a guy named Armine out in the Netherlands who was with ILCO back when they were doing their studies, wrote a paper on NixOS back then. He actually had an accident that he's been recovering from for a long time. So I thought in the sake of, there's a community out here and we care a lot about Nix, so maybe give him a shout out, a little feel better. So I was thinking like on 3, we can shout out Armine Feel Better. Is that cool with folks? Huh? He might be watching. So there's like, and if not, we can always pull it out from the recording. So, or yeah, record it and we'll send it to him. Ilko is carrying protein bars back from him, so that was the joke earlier. All right, on 3. Armine. Armine. Armine Hamel. All right. 1, 2, 3. Armine feel better. Thank you guys. That's awesome. I'm sure you'll appreciate it. All right. So before a quick vote, if folks want to come up front, we'll do a quick pick together, and then we'll do a vote. That'd be awesome. Only those that want to take a picture together.
Oh, hello. Hello. All right. While everybody's up here, you get 2 votes. Just put a tally next to it. Just put a tally. Hello. All right. So votes are in. Votes have been tallied. Here are the topics we're going to discuss. Number 1, debugging Nix, especially modules. Good luck with that. This corner, front left corner of the room. All right. Next one is new user Q&A. That's going to be back left corner of the room. Yeah, whichever direction that is. Next one is Nix and Python. That'll be up by the podium. And the next one is immutable NixOS appliances. That'll be back over by that door. All right? We have 2 whiteboards. First come, first serve. If you want it, good luck. Disperse. No. All right. This will make life easier. You can take some of these chairs and rearrange them. You have to unhook them. Sorry. You have to unhook them, but absolutely put them back where they were so that we don't make more work for the cleaning crew.
Oh, then you got the. I gotta return that. I have no idea where my walkie ended up.
All right, folks. It seems like we're all kind of assembled into our groups now. I'm going to let this just kind of run. You have about an hour before we have to kick people out. I have to go. I will be at SCaLE tomorrow. Thank you all for coming out. Hope you had a good time. Enjoy.